The origin of water on Earth. Have you ever wondered how the beautiful blue planet we live on began? How did a chaotic mass of molten rock transform into a stable planet with oceans and an atmosphere teeming with life? The story of Earth's formation isn't just a scientific explanation, but a miraculous journey full of surprises. Around 4.5 billion years ago, Earth was born from a protoplanetary disk, a chaotic collection of dust and gas surrounding the nascent sun. Through constant collisions of asteroids, meteoroids, and other debris, a massive molten sphere began to take shape. The immense heat generated by these collisions turned Earth's surface into a fiery ocean of magma. Yet, these harsh conditions were what allowed the planet to organize itself. Heavy elements like iron and nickel sank to the center to form Earth's core, while lighter elements rose to the surface, creating the crust and primitive atmosphere. This stratification not only provided Earth with its physical structure, but also laid the foundation for the magnetic field, a critical shield against cosmic radiation. According to NASA, during this period, Earth endured 10,000 to 20,000 major asteroid impacts daily. The planet's surface temperatures soared to 2,000 to 3,000 degrees Celsius, hot enough to melt any material. Simultaneously, the radioactive decay of elements like uranium and thorium within Earth's interior generated additional heat, keeping its core in a molten state for billions of years. The iron-nickel core didn't just stabilize the planet, it created a powerful magnetic field that protected Earth from solar wind and harmful cosmic rays. The story of Earth's early formation is not just a series of dry scientific facts. It's a testament to the power of nature, that even from the harshest conditions, a solid foundation can emerge. From chaos came order, as Earth prepared itself with the essential components to support life. It's akin to a person overcoming life's toughest challenges to achieve remarkable success. Imagine a blacksmith working with a block of iron. He must heat it in an intense fire until it melts, then carefully shape it into a sharp sword. Early Earth was much like that, a searing mass of material forged through collisions and heat into the stable planet we know today. From a fiery ocean of magma, Earth evolved into a place with a solid crust, ready for even greater changes ahead. Another study from ESA, European Space Agency, highlights that around 50% of Earth's material came from metal-rich asteroids. These impacts not only increased Earth's mass, but also delivered essential elements like iron, nickel, and radioactive isotopes that were crucial in maintaining the planet's internal heat. These components didn't just shape Earth's structure, but also set the stage for the formation of its atmosphere and life-supporting conditions. The formation of Earth was like a vibrant cosmic symphony, where each collision was a note and every magma flow a melody. These chaotic notes gradually came together to create a masterpiece, the planet we call home. This story reminds us that, even when starting from adverse conditions, persistence and nature always find a way to evolve and flourish. Looking back on this miraculous journey, we can't help but wonder, what came next? After its physical formation, Earth faced more significant challenges, especially in retaining water, the key ingredient for life. But that is a story for the next chapter. Did you know that water, the essential element for life, couldn't exist on early Earth? The reason wasn't due to a lack of water sources, but rather because of the planet's very first atmosphere. What made Earth's initial atmosphere incapable of retaining water? Earth's primordial atmosphere formed from gases released by its magma ocean and volcanic activity. At that time, the atmosphere mainly consisted of hydrogen, helium, along with other gases such as carbon dioxide, methane, and ammonia. However, This was a thin layer of gas with no ozone layer to shield it. Under the intense ultraviolet radiation from the sun, water molecules were split into hydrogen and oxygen. Being a light element, hydrogen easily escaped Earth's weak gravitational pull and drifted into space. This meant that any water present on early Earth was quickly lost. Moreover, the low atmospheric pressure made it impossible for liquid water to remain stable on the surface. The weak gravity of the young planet couldn't hold on to critical gases, causing the atmosphere to become even thinner. As a result, even with external sources of water from meteoroids or comets, Earth's atmosphere at the time couldn't retain them. According to ESA research, over 80% of the hydrogen in Earth's primordial atmosphere escaped into space within the first 100 million years. Additionally, solar radiation at the time was estimated to be 10 times more intense than it is today, destroying billions of tons of water annually. These figures highlight that early Earth's atmosphere was not only fragile, but also entirely unsuitable for retaining water, a crucial element for life. The story of Earth's primordial atmosphere serves as a powerful testament to the resilience and adaptability of our planet. Despite facing significant losses, Earth continued to evolve, finding ways to change and incorporate the necessary elements to prepare for life. It's a reminder that even in conditions that seem insurmountable, there's always room for growth and progress. Imagine planting a seed in barren soil. While it might lack the ideal conditions initially, with persistence in watering and nurturing the soil, it can eventually become fertile, allowing the seed to sprout. Similarly, Earth gradually accumulated the factors needed to transform into a habitable planet. Studies from the Hubble Space Telescope reveal that during the early solar system, ultraviolet radiation destroyed billions of tons of water annually on Earth's surface. This loss was only offset by external contributions, such as water-rich meteoroids and comets, a subject that will be explored further in the next chapter. The primordial atmosphere was like a thin protective shield, insufficient to fend off the harsh forces of the cosmos. Yet, it laid the groundwork for crucial changes and evolution. The journey of Earth isn't just a tale of challenges, it's a testament to perseverance in the face of adversity. Looking back, even though it couldn't retain water initially, Earth's first atmosphere paved the way for the arrival of external elements from the cosmos. These elements transformed the planet into a life-sustaining haven. But that story belongs to the next chapter of this miraculous journey. Have you ever thought that water on Earth, the essential element for life, wasn't created by the planet itself, but was a gift from the cosmos? Extraterrestrial visitors, asteroids, and comets were the water carriers that enriched our planet as we know it today. When Earth first formed, its internal factors weren't sufficient to produce the amount of water necessary for life. During a period known as the Late Heavy Bombardment, approximately 3.8 to 4.1 billion years ago, numerous asteroids and comets bombarded the planets in the solar system, including Earth. Carbon-rich asteroids, especially carbonaceous chondrites, carried water-bound minerals, while comets from distant regions like the Oort cloud brought ice and gases to the planet. When these objects collided with Earth's surface, water and organic compounds were released, providing the crucial ingredients needed for ocean formation. According to NASA, these collisions delivered an enormous volume of water to Earth. A report from the OSIRIS-REx mission revealed that asteroids like Bennu contain up to 5% of their mass in water, bound within minerals. Additionally, analyses of Comet 67P Churyumov-Gerasimenko by ESA found that the isotope ratio of water in the comet closely resembles that of Earth's water. This strongly suggests that a significant portion of Earth's water could have originated from such celestial bodies. The journey of water to Earth is a deeply inspiring story. From the farthest reaches of the cosmos, water traveled across billions of light years, enduring violent impacts to arrive here. It's almost like nature's message that even in the harshest conditions, it finds a way to enable life to thrive. Imagine a summer rainstorm pouring over a barren land. Those seemingly insignificant drops of rain combine to revive an entire area. Similarly, asteroids and comets delivered water to Earth, drop by drop, eventually creating the vast oceans we see today. Research from ESA indicates that during the late heavy bombardment, up to 10 billion tons of material from asteroids and comets rained down on Earth each year. This influx not only brought water, but also delivered organic compounds like amino acids, the building blocks of life. These components not only played a crucial role in forming water, but also catalyzed the chemical processes necessary for life. The journey of water to Earth isn't just a series of scientific events. It's a symbolic story of cosmic connection. Every drop of water on this planet stands as evidence of the incredible collaboration between planets, celestial objects, and time itself. It reminds us that, in the vast universe, everything is interconnected to create miracles. After water arrived, another big question arose. How did Earth retain this water? The journey of retaining and stabilizing water will be explored in the next chapter. Have you ever wondered how distant rocks from outer space could hold the key to the formation of life on Earth? Carbonaceous chondrites, a type of meteorite rich in carbon and water, are not just ancient fragments of the solar system, but also vital carriers of water to our planet. Carbonaceous chondrites are space rocks with a history spanning billions of years, containing water-bearing minerals. These meteorites formed during the early stages of the solar system and have been preserved nearly intact. They hold hydrated minerals, meaning water is trapped within their structure. When these meteorites collided with Earth during the late heavy bombardment, 3.8 to 4.1 billion years ago, the heat and impact released their water and organic compounds into the planet's environment. Over time, these droplets of water accumulated and became part of Earth's primordial oceans, laying the groundwork for the development of life. According to NASA, carbonaceous chondrites like Bennu contain up to 5% of their mass as water in the form of minerals. Chemical analyses reveal that the isotopic ratio of water in these meteorites closely matches that of Earth's water, supporting the hypothesis that they were among the first water sources for the planet. Additionally, these meteorites carried amino acids and organic compounds essential for life. Carbonaceous chondrites didn't just bring water, they carried the seeds of life. Imagine that from the farthest corners of the universe, they delivered precious water droplets and organic compounds, like messengers of hope to a nascent planet. This isn't just science. It's a deeply inspiring story of how the universe operates harmoniously and marvelously. Imagine holding a small rock in your hand, seemingly ordinary, but inside, it holds water molecules locked within minerals and ancient organic compounds. That's exactly how these meteorites contributed to the formation of oceans and the atmosphere on Earth. Another report from ESA notes that carbonaceous chondrites accounted for about 3% of all meteorites that fell to Earth during the late heavy bombardment. However, these specific meteorites delivered a vast amount of water, enough to transform the planet's landscape completely. Water isn't merely a liquid. It's the foundation for every biochemical activity essential to life. These carbonaceous chondrites are like priceless gems, preserved for billions of years in space. When they collided with Earth, they carried messages from the solar system's infancy. This doesn't just open the door to science, but also raises profound questions about the connection between the universe and our planet. Looking back at the journey of these meteorites, one can't help but wonder, without these water-rich and organic-laden rocks, could Earth have become the life-filled planet it is today? This question bridges us to the next part of the journey, exploring the role of comets, the companions in bringing water to the blue planet. Have you ever wondered how comets, with their icy and mysterious appearance, traveling from the farthest reaches of the solar system, played a crucial role in forming Earth's oceans? These celestial messengers brought water and essential elements, becoming a vital source of life for our blue planet. Comets, celestial bodies primarily composed of ice, dust, and gases like carbon dioxide and methane, originate from the most distant regions of the solar system, such as the Oort cloud and Kuiper belt. They are mobile water reservoirs carrying billions of tons of ice and water vapor. During the late heavy bombardment, 3.8 to 4.1 billion years ago, as comets collided with Earth, their ice melted, releasing vast quantities of water and contributing to the planet's water supply. Beyond water, comets also delivered organic compounds like amino acids, laying the foundation for the chemical reactions necessary to form life. According to research from ESA, the Rosetta probe discovered that Comet 67P Churyumov-Gerasimenko contained water with a deuterium to hydrogen ratio similar to Earth's water, suggesting that part of the planet's water may have originated from comets. Additionally, NASA estimates that water from comets accounts for up to 20% of Earth's current water supply. This remarkable figure highlights the essential role of comets in transporting water from distant regions to our planet. The story of comets bringing water to Earth isn't just a scientific tale. It's a cosmic symphony full of inspiration. From the farthest reaches, crossing icy voids, tiny ice particles arrived and transformed the history of the planet. This is proof that even the smallest and most distant elements can lead to monumental changes. Imagine the first rains of the season falling on parched soil. Every drop is a gift, a sign of hope, and as they accumulate, an entire area comes back to life. Comets are like these cosmic raindrops, bringing water and breath to Earth during its formative years. A report from NASA notes that during the late heavy bombardment, thousands of comets struck Earth, delivering billions of tons of water annually. Alongside water, their accompanying organic compounds played a crucial role in forming the chemical precursors necessary for life. This marked a pivotal point in Earth's transformation from a barren planet to one filled with vast blue oceans. Comets are unique visitors from the cosmos, carrying secrets from the solar system's earliest days. Each of their encounters is a gift, a reminder that the universe is not just an empty expanse, but a nurturing network, connecting planets through natural elements like water and gases. Looking back, comets were indispensable in forming Earth's water supply. However, their role didn't stand alone. Combined with meteorites, they created a comprehensive network for water supplementation, shaping the planet's landscape and paving the way for life to thrive. Have you ever wondered what transformed Earth from a barren rock into the blue planet filled with water? The answer lies not in a single factor, but in the extraordinary collaboration between meteorites and comets, two celestial visitors that brought water and life to our planet. Meteorites and comets, despite their different origins and characteristics, jointly contributed to forming Earth's massive water supply. Meteorites, especially carbonaceous chondrites, carried water-bearing minerals and essential organic compounds. Meanwhile, comets from the Oort cloud and Kuiper belt delivered ice and gases, adding substantial amounts of water to the planet. Together, these two sources created enough water to form oceans and introduce the chemical elements necessary for initiating biological processes. According to NASA, impacts from meteorites and comets during the late heavy bombardment brought billions of tons of water annually. A report from ESA indicates that approximately 20% of Earth's water may have come from comets, while the majority originated from carbonaceous chondrites. This combination not only provided water, but also established a chemical balance, with organic compounds from meteorites and gases from comets. This story isn't just a scientific depiction of planetary formation, but also a profound lesson in collaboration and synergy. If only meteorites had contributed, Earth would lack significant ice and gases. If only comets were involved, the planet would miss crucial minerals and organic compounds. The combination of both was the decisive factor, akin to how different musical instruments come together to create a complete symphony. Imagine a farmer sowing seeds in arid soil. They need water to soften the ground, like the melting ice from comets, and fertilizer to enrich the soil, like organic compounds from meteorites. Only with both elements can the seeds grow robustly. Similarly, early Earth needed both water and chemical elements from two distinct sources to become a life-supporting planet. A report from the OSIRIS-REx mission revealed that carbonaceous chondrites contain up to 5% of their mass as water and carry amino acids, the building blocks of life. Meanwhile, Comet 67P/Churyumov-Gerasimenko, studied by the Rosetta probe, showed a deuterium ratio in its water closely matching that of Earth's, reinforcing the theory that comets significantly contributed to the planet's water. The combined roles of meteorites and comets are like pieces of a complete puzzle, each playing a unique but indispensable part in the larger picture. It reminds us of nature's incredible collaboration in fostering life. Despite their different origins, both meteorites and comets shared a common purpose: to fill this planet with water and the essentials for life. Reflecting on the contributions of meteorites and comets, we see not only the creation of a water-rich planet, but also a profound lesson about interconnectedness in the universe. This collaboration sets the stage for exploring the next scientific stories of Earth's journey toward hosting life. Did you know that volcanoes, with their violent eruptions, are not just symbols of destruction, but also natural engines that contribute to Earth's precious water supply? Let's explore how water vapor from deep within the Earth has played a crucial role in forming the planet's early oceans. Water vapor is one of the primary components released during volcanic eruptions, especially in Earth's early history. When the planet was young, eruptions were frequent, releasing large amounts of water vapor, along with gases like carbon dioxide and methane, into the atmosphere. As the water vapor cooled, it condensed and fell as rain, creating lakes and the first oceans. Volcanic activity wasn't just a geological phenomenon. It was a major driver of the water cycle. The intense heat and eruptions brought water vapor from deep within the Earth to the surface, contributing to the accumulation of liquid water. This process marked the beginning of Earth's hydrological cycle, which became the foundation for life. According to NASA, over 70% of Earth's primordial water may have been formed from volcanic activity during the planet's early stages. Massive eruptions more than 4 billion years ago are believed to have released billions of tons of water vapor into the atmosphere, laying the groundwork for the oceans we see today. From what seemed like destructive chaos, Earth found a way to regenerate itself. Volcanoes are not just symbols of chaos, but are proof of nature's ability to rebuild and bring life from within. The image of the first raindrops formed from volcanic vapor settling on a barren surface is a powerful symbol of the birth of a blue planet. Imagine boiling a pot of water. As steam rises and encounters a cooler surface, it condenses into tiny droplets. Early Earth worked in a similar way. Volcanic eruptions released water vapor that condensed into liquid water, eventually forming vast oceans. Research from the USGS indicates that a modern volcanic eruption can release up to 400 million tons of water vapor into the atmosphere. This figure was significantly larger in Earth's early stages, when eruptions were continuous and on a massive scale. Volcanoes, with their rugged and chaotic appearance, are nature's silent workers. Through intense eruptions, they continuously brought water vapor from the depths of the Earth to the surface, helping to shape a water-filled planet. This story is not just about geology, but also a profound lesson in transformation and renewal. While volcanic eruptions provided the foundation for Earth's water, they are only part of the story. To retain this water and sustain life over time, Earth needed more complex mechanisms, such as plate tectonics. This is the focus of the next chapter. Have you ever wondered, if volcanic water vapor gave birth to water on Earth, what kept it here for billions of years? The answer lies in tectonic plate activity, a miraculous mechanism that helps retain and recycle water, ensuring this planet remains life-sustaining. Tectonic plate activity involves the movement of Earth's crustal plates, including their collisions, separations, and lateral shifts. This process is not merely geological, it is a pivotal factor in retaining water on Earth. As tectonic plates shift, surface water is drawn down into subduction zones, where oceanic plates sink beneath continental plates. Here, water is trapped within hydrated minerals or buried deep underground. These subduction zones not only store water, but also facilitate its recycling. As temperature and pressure increase, water is released from the minerals and returned to the surface through volcanic eruptions. This cyclical process functions as a giant water circulation system, ensuring that water isn't lost entirely to space, but remains within Earth's system. Moreover, tectonic activity stabilizes Earth's climate by regulating water loss through the carbonate-silicate cycle. In this process, carbon dioxide is absorbed into the Earth through chemical reactions, helping maintain the planet's temperature and preventing excessive evaporation of surface water. According to NASA, approximately 80% of water subducted into subduction zones is returned to the surface through volcanic activity. A report from the U.S. Geological Survey, USGS, further indicates that tectonic plates transport billions of tons of water annually as part of this recycling process. This underscores the indispensable role of plate tectonics in maintaining Earth's water supply. Think of a deep well that draws water from underground to the surface. Tectonic activity functions similarly to a natural well, ensuring Earth never runs out of water. Through the silent movement of tectonic plates, this planet has retained its precious life source for billions of years. Imagine a massive storm flooding an area with water. Without reservoirs and rivers to store and reuse this water, it would quickly disappear. Similarly, tectonic plate activity acts as Earth's reservoir, holding onto water and releasing it as needed, just like rain refilling rivers and lakes. A study from the University of California reveals that approximately 4 billion tons of water are subducted into the Earth's interior annually through subduction zones, with a significant portion returning via volcanic eruptions. These figures highlight the efficiency of the water recycling cycle governed by tectonic activity. Tectonic plate activity is more than just crustal shifts. It is Earth's beating heart, driving the water cycle and sustaining life. If Earth were a living organism, Tectonic activity would be its circulatory system, keeping the planet vibrant with water and life. The ever-moving tectonic plates have safeguarded Earth's water for billions of years. However, to fully understand how water is retained and recycled, we must consider both internal and external factors. This is the focus of the next section, where we explore the combined theories of internal and external contributions to Earth's water formation. Have you ever wondered how Earth's water originated not only from outer space, but also from within the planet itself? The story of water formation is a complex one, where both internal and external factors work together to create the wonder of our blue planet. The combined theory of Earth's water origin explains that water was not only delivered by comets and meteorites, but also formed through internal processes within the planet. Internal factors include water vapor from volcanic eruptions and the tectonic plate cycle, two mechanisms that helped Earth retain and recycle its water over billions of years. Meanwhile, external factors such as carbonaceous chondrite meteorites and comets brought water and organic compounds from distant corners of the universe. This combination created a complete system, where internal and external factors complemented each other. Meteorites delivered water and essential carbon compounds, while internal processes safeguarded and recycled this precious resource. Each factor played its own role, but their harmony ensured Earth's stable and abundant water supply, the cornerstone of life. According to NASA, approximately 20 to 30% of Earth's water came from comets and meteorites, while 70 to 80% originated from internal processes like volcanic activity and tectonic recycling. Reports from ESA also revealed that water from carbonaceous chondrites has a deuterium to hydrogen ratio similar to Earth's water, supporting the combined theory of external and internal contributions. The image of water, an essential element of life, formed through the collaboration of the vast universe and our small planet, is a marvelous testament to nature's balance. From violent volcanic eruptions to distant meteorites piercing Earth's atmosphere, all have worked together to transform Earth into a haven for life. Imagine preparing a perfect meal. Basic ingredients like rice, vegetables, and water must be sourced externally, but cooking and preservation rely entirely on your internal skills. Similarly, Earth depends on external factors to provide the materials, while internal processes ensure sustainable use and storage. According to Nature Geoscience, internal processes could produce up to 100 million tons of water annually through subduction zones and volcanic cycles. Combined with billions of tons of water delivered by meteorites during the late heavy bombardment, Earth became the only planet in the solar system to possess such an abundant water supply. The combined theory of internal and external contributions is not just a story of geology or astronomy. It's like a symphony, where different instruments blend to create a perfect melody. This demonstrates the connection and balance in nature, where every factor contributes to a sustainable ecosystem. The interplay between internal and external factors not only formed Earth's water, but also laid the foundation for life. This raises bigger questions. Could other planets in the universe have a similar balance to sustain water and life? The answers may lie in future explorations of exoplanets. The unique atmosphere of Neptune. Have you ever wondered how a planet more than 4 billion kilometers away from the Sun can radiate such a mesmerizing blue hue? The secret behind this captivating color lies not only in light, but also in the unique structure of its atmosphere, a realm filled with characteristics found nowhere else. Neptune's atmosphere is like a magical cloak, composed mainly of 3 key elements: hydrogen, 80%, helium, 19%, and a small amount of methane, 2%. Methane plays the primary role in absorbing the sun's red light and reflecting blue light, creating Neptune's signature blue appearance. But the story doesn't stop with methane. Recent studies from the James Webb Space Telescope, JWST, reveal that high-altitude haze and dust particles within Neptune's atmosphere further enhance the blue glow. What sets Neptune apart from other gas giants, such as Jupiter or Saturn, is how its atmospheric dynamics amplify this effect. Not only beautiful, but this atmosphere is also incredibly harsh. With an average temperature of -218 degrees Celsius, Neptune's atmosphere is the coldest in the solar system. This extreme cold causes gas molecules to slow down, resulting in a stable but highly energetic atmospheric layer. According to NASA data, the pressure in Neptune's lower atmosphere can reach up to 100,000 atmospheres, thousands of times stronger than Earth's atmospheric pressure. The thin methane layer is crucial, absorbing most red light and amplifying the blue light intensity at short wavelengths, 600 to 800 nanometers. Additionally, the temperature plummets significantly with altitude, giving each atmospheric layer its unique physical properties. Neptune's atmosphere feels like a magical blue veil within the vast universe, where every beam of light tells a story. This color is not just a physical phenomenon, but a testament to the unmatched beauty of nature. It reminds us that even in the harshest conditions, nature continues to craft wonders. Imagine looking down from an airplane window, gazing at a deep blue ocean. That color reflects sunlight, evoking peace and mystery. Similarly, Neptune's atmosphere functions as a sea of light in the cosmos. But instead of water, it is composed of methane and hydrogen. Hubble telescope data reveal that Neptune's cloud layers are 20 to 30 kilometers thick, stretching across thousands of kilometers. Scientists have found that under high pressure, methane can crystallize into microscopic ice forms, contributing to the varying light reflections between atmospheric layers. If Neptune were a piece of art, its atmosphere would be the vivid palette the universe used to paint it. Each atmospheric layer is a shade of color, each methane molecule a perfect stroke of the brush. And we, the spectators from afar, are left mesmerized by this cosmic masterpiece. The blue atmosphere is not just visually stunning, but also a dynamic system filled with complexity. Constantly shifting and evolving, it gives rise to fierce storms and unusual hotspots, phenomena we will explore in the next part. Storms and winds on Neptune. Can you believe that Neptune, the farthest, coldest planet in the solar system, hosts the most powerful storms ever recorded? With wind speeds reaching 1,300 miles per hour, 2,100 kilometers per hour, the weather phenomena here are not just a testament to nature's strength, but also a reminder of the perpetual chaos of the universe. Neptune's storms and winds are a clear demonstration of its harsh environment. One of its most striking features is the dark spot, first discovered in 1989 by Voyager 2. These storms are massive, with diameters reaching up to 10,000 kilometers, equivalent to the size of Earth. Unlike storms on our planet, the dark spot on Neptune not only lasts longer, but also boasts the strongest winds ever recorded in the solar system, 3 times stronger than the most intense hurricanes on Earth. These powerful storms arise from the large temperature differences between the lower and upper atmospheric layers, where energy from the planet's core is still being released. Moreover, Neptune lacks a solid surface to slow down air currents like Earth, allowing these storms to persist and intensify significantly. According to NASA, wind speeds on Neptune can reach up to 2,100 kilometers per hour, while the most intense storm on Earth, Typhoon Haiyan, had maximum winds of only 315 kilometers per hour. Another study by the Hubble telescope revealed that storms like the dark spot can last from several months to several years, depending on atmospheric conditions. The storms on Neptune are a testament to nature's unstoppable power. They highlight the planet's harshness while inspiring us, reminding us that the universe is constantly in motion, even in the farthest reaches. Such phenomena make us feel small, yet they also fuel our boundless curiosity to explore. Imagine a storm like Typhoon Haiyan, but twice the size and 3 times as strong. Instead of sweeping across Earth's blue oceans, it swirls in Neptune's deep azure atmosphere. The only difference is that, on Neptune, there's no landmass for these storms to stop. Data from Voyager 2 and the Hubble telescope show that Neptune storms often originate in lower atmospheric layers, where temperatures are warmer and spread to higher altitudes. These storms are surrounded by high-pressure systems, forming powerful wind vortices. A 2021 study using the James Webb Telescope also revealed that these phenomena are tied to energy released from the planet's core, driving the ceaseless movement of atmospheric currents. Think of these storms as ferocious dances of nature on a cold, distant stage. Each storm is a testament to the chaos and creativity of the universe. It's not just destruction, but also motion, a constant rebalancing of natural forces. These superspeed storms are just one part of Neptune's incredible meteorological landscape. Beyond the swirling vortices, its atmosphere also hosts unusual hotspots, mysterious areas of warmth. Let's delve into these phenomena in the next section to understand more about the power of this distant planet. Hotspots and complex atmospheric structures. Have you ever thought that a frigid planet like Neptune could harbor peculiar regions of unexpected warmth, where temperatures rise significantly above their surroundings? These hotspots not only raise questions about the planet's atmospheric nature, but also offer clues to the unique physical processes occurring there. Hotspots on Neptune are among the most fascinating atmospheric phenomena ever recorded. These areas often appear near the planet's southern pole, moving with powerful air currents. Hotspots exhibit temperatures 10 to 20 degrees Celsius, higher than their surroundings, which is remarkable for a planet as cold as Neptune, where the average temperature is minus 218 degrees Celsius. Scientists believe that hotspots form due to atmospheric turbulence as energy from the planet's core is released, combined with the motion of high-altitude winds. This phenomenon is particularly intriguing because it sheds light on how a distant planet, receiving minimal solar warmth, maintains such dynamic atmospheric activity. According to data from the James Webb Space Telescope, JWST, hotspots on Neptune are often associated with large storms and low-pressure systems in the atmosphere. These regions are not only warmer, but also have lower gas density, allowing infrared light to pass through and detect them. A 2022 NASA study revealed that hotspots might exist for short periods, from a few weeks to a few months, before being dispersed by strong winds. These hotspots are not merely physical phenomena, but also inspire profound curiosity and awe. They resemble small sparks of hope amidst the frigid, dark expanse of space. The image of a cold, blue planet, with flashes of unexpected warmth, evokes the boundless creative power of the universe, where every phenomenon tells a story waiting to be uncovered. Imagine sitting by a cozy fireplace on a freezing winter night, feeling the warmth radiate through the chill. Neptune's hotspots are much like that, mysterious and sudden sources of energy amidst a frozen expanse, exemplifying the planet's latent vibrancy. Additionally, data from the Hubble telescope indicate that the formation of hotspots is linked to high-altitude methane clouds in the atmosphere. These clouds can reflect and diffuse heat, contributing to the temperature differences between regions. Moreover, the presence of methane in these areas enhances the ability to detect hotspots through infrared light. If Neptune is a microcosm of the universe, its hotspots are small yet potent flames, illuminating the planet's depths. These regions demonstrate that even in the harshest conditions, there is vitality and surprise. The beauty of the universe lies not just in its grandeur, but also in the delicate balance of seemingly opposing forces. Hotspots are just one part of the broader picture of Neptune's atmospheric structure, where complexity and dynamism coexist. These warm regions pave the way for understanding other aerodynamic phenomena, including strong storms and high-altitude winds. They are a testament to how the universe continually keeps humanity astonished and eager to explore further. The unique characteristics of Triton. Have you ever wondered, among the hundreds of moons in the solar system, what makes Triton, Neptune's largest moon, stand out? The answer lies in its peculiar and fascinating features, from its retrograde orbit to its massive ice plumes, all of which create a world full of mystery and allure. Triton is one of the most unusual moons in the solar system because it orbits Neptune in a retrograde direction, opposite to the planet's rotation. This rarity leads scientists to believe that Triton was not formed alongside Neptune, but was originally a celestial body in the Kuiper Belt, later captured by Neptune's gravity. With a diameter of approximately 2,706 kilometers, Triton is the seventh largest moon in the solar system and even larger than Pluto. Its surface is a reflective layer of nitrogen ice, making Triton one of the brightest moons when viewed from space. Remarkably, Triton's surface shows minimal large impact craters, indicating a history of strong geological activity that has erased evidence of past collisions. According to data from Voyager 2, Triton's surface temperature is around -235 degrees Celsius, making it one of the coldest objects in the solar system. Additionally, its ice plumes can release nitrogen gas and dust up to 8 kilometers high, creating a thin atmosphere around this moon. This rare characteristic demonstrates that Triton is still geologically active. Triton is like a cold, shining jewel in space, glittering but hiding many unanswered mysteries within. Its image captivates not only scientists, but also inspires endless wonder about the incredible phenomena the universe has to offer. Triton reminds us that even the most distant and frigid places can possess vibrancy and undeniable beauty. Imagine holding a crystal stone sparkling under sunlight, with every angle revealing a unique shimmer. Triton is much the same, but instead of sunlight, it reflects light from its nitrogen ice surface, leaving scientists in awe. This beauty is not just a physical phenomenon, but a testament to the richness of nature in outer space. Studies from the Hubble Space Telescope reveal that Triton's surface contains numerous organic compounds, particularly methane and nitrogen. These compounds not only contribute to its highly reflective surface, but also hint at the potential for complex chemical reactions in Triton's past. Additionally, Triton has a density of approximately 2.06 grams per cubic centimeter, suggesting a large rocky core beneath its icy shell. Triton is not just a moon, it's an untold story. With its retrograde orbit, icy surface, and ice plumes, Triton is a symbol of uniqueness and extraordinariness in the solar system. It makes us reflect on the strange and wonderful, that in the diversity of the universe, everything has a reason and a story of its own. Triton is not just a marvel of the solar system, but also a key to exploring the origins and history of celestial bodies in the Kuiper Belt. Yet its beauty and uniqueness do not stop at its orbit or surface, but extend to its climate and geological activity. Mysteries that will continue to be explored in the next section. Climate and unique geology. Have you ever thought that a distant icy moon like Triton could harbor a unique climate system and remarkable geological activity? Seasonal changes and massive nitrogen ice flows on its surface not only highlight the vibrancy of this moon, but also unlock mysteries about how the universe operates under the harshest conditions. Triton's climate is influenced by its retrograde orbit and unique distance from Neptune. As Triton approaches or recedes from Neptune during its orbital cycle, nitrogen ice patches on its surface sublimate into gas, creating extraordinary weather phenomena. Seasons on Triton are unlike any other in the solar system. A strange combination of extreme cold and continuous movement of nitrogen gas molecules. At the same time, Triton's geology is equally fascinating. Massive nitrogen plumes, rising kilometers into the atmosphere as observed by Voyager 2, are clear evidence of the moon's intense geological activity. Beneath the thick ice surface, liquid flows may form due to internal heat generated by its core and tidal interactions with Neptune. According to Voyager 2 data, Triton's surface has almost no large impact craters, indicating it is constantly being restructured by nitrogen ice flows. Some studies estimate that nitrogen ice sublimation during Triton's summer could reach hundreds of tons per day, enough to alter the pressure in its thin atmosphere. Additionally, low-pressure systems and strong winds create aerodynamics similar to Earth's weather phenomena, but on an entirely different scale. The image of nitrogen plumes on Triton resembles giant white smoke columns, reaching into the dark space, both majestic and mysterious. They evoke a sense of awe at nature's power, reminding us that even the most barren places can hold constant motion and energy. If you have ever witnessed a geyser erupting in Yellowstone amid wild nature, you can imagine the nitrogen plumes on Triton. But instead of hot water, here it is liquid nitrogen being ejected from the icy surface, creating an equally impressive spectacle. Hubble telescope data reveal that nitrogen ice on Triton can exist in multiple states: solid, liquid, and gas. The transitions between these states not only affect the surface, but also alter the structure of its thin atmospheric layer. A report from ESA indicates that nitrogen plumes can release millions of cubic meters of gas annually, contributing to maintaining atmospheric pressure on Triton. Triton's climate and geology are proof of the universe's vitality, even in its harshest environments. They remind us that the cosmos is in constant motion, creating and sustaining phenomena that humans will need centuries to fully understand. These climate and geological activities are just the tip of the iceberg on Triton. Beneath its thick nitrogen ice lies countless secrets waiting to be uncovered. Could we find a liquid water ocean and, even more, signs of primitive life? These questions will guide future exploration missions. The potential for life. Have you ever wondered whether a distant icy world like Triton, Neptune's largest moon, could harbor life? While its surface is covered in frigid nitrogen ice, research suggests that beneath this icy layer, a liquid water ocean may lie, offering a possible haven for life. Scientists believe that Triton, like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, might have a liquid water ocean beneath its thick ice layer, maintained by heat from its core and tidal interactions with Neptune. This ocean could provide the perfect environment for sustaining life, as liquid water is a fundamental requirement for all known life forms. Moreover, organic compounds have been detected on Triton's surface through nitrogen and gas plumes, raising the possibility of microbial life. If this ocean also contains energy sources, such as hydrogen, the conditions for supporting simple life forms could become viable. According to NASA, Voyager 2 discovered that Triton's thin atmosphere contains compounds like methane and nitrogen, both of which are crucial for chemical reactions linked to life. Other studies suggest that nitrogen ice flows on Triton's surface might carry nutrients from beneath the ocean, fostering life in these extreme environments. Triton evokes wonder about the marvels the universe might be hiding. The thought that beneath its icy, desolate exterior, there could be life is a powerful source of hope and aspiration. It shows that even in the harshest conditions, life can find a way to exist. Imagine standing by a frozen lake in winter, where a thick ice layer hides the life thriving below. Triton is much the same. Its nitrogen ice layer acts as a veil hiding a potential world beneath. This makes us wonder, if life can exist there, how many other secrets does the universe hold? A study by the European Space Agency, ESA, suggested that heat from Triton's core could sustain liquid water for millions of years. The organic compounds found on its surface and atmosphere strongly indicate the possibility of complex chemical reactions, the first steps toward life. Triton is a world of mystery and opportunity. If life is found there, it will not only change how we understand the universe, but also offer hope that life might be more common than previously believed. The search for life on Triton reminds us that the universe is full of surprises, and every technological advance brings us closer to answers. Future missions, such as sending probes to Triton, could unlock these secrets. The possibility of discovering life on Triton is not just a scientific question, but a profound inspiration, driving humanity to push the boundaries of exploration and reach for the stars. Structure and composition of the rings. Have you ever imagined that in a distant place like Neptune, there exists a mysterious ring system, not as radiant as Saturn's, yet full of surprising scientific stories? Neptune's faint rings are a testament to the complexity of the universe, where even the smallest details play a crucial role in the solar system's larger picture. Neptune's rings consist of 5 main arcs: Gale, Leverrier, Lassell, Arago, and Adams. Unlike the bright rings of Saturn, these are fainter and primarily composed of ice, dust, and small debris. Notably, the Adams ring stands out with its arcs, dense regions where ice and dust particles cluster together under the gravitational influence of the moon Galatea. These arcs defy conventional theories about particle movement and stability in space, making them a unique phenomenon in the solar system. According to Voyager 2 data, the particle sizes in the rings range from a few micrometers to several meters. Though faint, they can reflect sunlight, creating faint streaks visible through telescopes. Some studies suggest that Neptune's rings might result from collisions between small moons or destroyed celestial bodies, leaving debris in orbit around the planet. Neptune's ring system resembles a quiet embrace around the giant planet, subtle yet vital. It evokes awe at the power of nature, showing that even seemingly simple structures can provide profound insights into the universe. Imagine standing before an ancient necklace, where each small bead holds a fragment of history. Neptune's rings are much the same. Each dust particle, each ice fragment tells a story of the planet's formation and evolution, as well as the collisions that shape their orbits. A 2021 NASA study revealed that the Adams ring has varying densities, with its arcs moving slowly and maintaining position for decades due to Galatea's gravitational pull. This not only explains the stability of the arcs, but also raises many questions about ring dynamics in planetary systems. Neptune's rings are not just an astronomical phenomenon, but a part of a larger narrative about how the universe formed and evolved. They are a reminder that, in the vastness of space, every element, no matter how small, holds value in constructing the complete picture of nature. Discoveries from telescopes. Have you ever wondered how scientists can see and study Neptune's faint rings from billions of kilometers away? The answer lies in humanity's ingenious eyes, modern space telescopes, which have opened the doors to exploring the mysterious and fascinating world of this planet. The discovery of Neptune's rings began in 1989 with the historic flyby of Voyager 2, which provided the first images of the planet's faint structures. However, observations did not stop there. Thanks to advanced space telescopes like Hubble and James Webb, scientists have continued to gather data, shedding light on the structure and composition of the rings. Telescopes use infrared and ultraviolet light to detect the dust and ice particles reflecting light, helping to determine their chemical composition and optical properties. Notably, images from James Webb have shown the arcs within the atom's ring moving slowly and changing position over time, providing valuable clues about the dynamics of the ring system. According to NASA, observations from Hubble and James Webb revealed that ice particles in Neptune's rings not only reflect light, but also absorb some sunlight. This suggests they contain organic compounds or silicates, offering insights into how these particles formed and evolved. A 2022 ESA report also highlighted that the James Webb Telescope captured more detailed images of the arcs, enabling scientists to study how they maintain stability over long periods. The images of Neptune's rings, though faint, evoke a sense of wonder about the complexity of the universe. Telescope data are not merely dry numbers, but vivid stories of fascinating astronomical phenomena, showing that even seemingly invisible elements can hold profound secrets. Imagine using a magnifying glass to closely examine the fine details of a leaf. Telescopes work similarly, but instead of exploring the near at hand, they unveil unimaginable vistas, allowing us to explore things beyond human sight, like the tiny ice particles in Neptune's rings. Another ESA study found that modern telescopes can analyze the light reflected from particles in the rings to determine their age. Results showed that some ice particles in the rings might have existed for millions of years, retaining their state from when the solar system first formed. Telescopes are not just research tools, but symbols of human curiosity and ingenuity. They allow us to transcend the boundaries of time and space to see the seemingly impossible. Through this, every discovery about Neptune and its rings carries not only scientific meaning, but also inspiration for future generations. The data from telescopes have opened a new chapter in studying planetary ring systems, but this is just the beginning. Scientists are planning future missions to get closer to Neptune, providing deeper insights into this planet. The connection between advanced technology and the desire to explore will continue to drive us to uncover the grand secrets of the universe. The importance of research. Have you ever wondered why humanity spends decades studying the faint rings around Neptune, the farthest planet in the solar system? Could these seemingly small structures truly hold significant value? The answer lies not only in scientific data, but also in a deeper understanding of the universe's origins and future. Researching Neptune's rings does more than help us understand this distant planet. It provides invaluable clues about how the solar system formed and evolved. These rings, composed of ice, dust, and small debris, are remnants of past collisions. They reflect the planet's history and surrounding environment. Analyzing their composition not only reveals how particles interact, but also provides critical data to compare with other giant planets like Saturn and Jupiter. Through this, we can decode broader questions about how planets and moons form in other star systems. According to NASA, Studies of Neptune's rings have allowed scientists to determine that some ice particles in the arcs of the atom's ring contain organic compounds, similar to those found in the Kuiper Belt. This discovery not only sheds light on how these particles formed, but also opens the door to further research on objects beyond the solar system. Thinking about such research evokes the magic of science. Exploring faint and nearly invisible structures is not merely the work of scientists. It is a reminder that curiosity and discovery are fundamental to humanity. These rings, though small, hold a bigger story about life and the universe. Imagine reading an ancient book where each fragile page holds a vital part of the story. Neptune's rings are much the same. Each dust particle, each ice fragment plays its role in telling the tale of the planet's formation and evolution. A report from ESA highlights that studying the dynamics of Neptune's rings could apply to understanding dust disks around young stars in other star systems. This represents a major advancement in expanding our knowledge of exoplanets and unlocking the mysteries of planetary systems similar to our own solar system. Research is not just about collecting data. It is a testament to humanity's creativity and technological progress. Every step forward in understanding Neptune and its rings brings us closer to decoding the universe's bigger mysteries, inspiring future generations to continue exploring. The discoveries from current studies are only the beginning. Future space missions to Neptune will provide even more detailed data, clarifying the role of the rings in shaping the planet's surrounding space environment. This is not just a scientific journey, but a testament to humanity's unbounded drive for exploration. Have you ever imagined a planet over 1.2 billion kilometers away hosting a weather phenomenon so extraordinary it defies conventional understanding? At Saturn's North Pole, a massive hexagonal storm has existed for centuries, challenging our imagination and raising profound questions about how the universe operates. The hexagonal storm at Saturn's North Pole is not just a unique phenomenon, but also a scientific puzzle with no definitive answer. Spanning over 30,000 kilometers in diameter, large enough to fit 3 Earths, this storm rotates around a central eye. First discovered in 1980 by Voyager 1, it was later studied in greater detail by the Cassini spacecraft from 2004 to 2017. The hexagonal shape is formed by powerful convection currents swirling around the North Pole at speeds of up to 320 kilometers per hour. What's remarkable is that this structure has maintained its shape for decades without distortion. Scientists suggest its stability might stem from a unique aerodynamic mechanism, where high-speed gas streams interact to create a perfect geometric pattern. Data from Cassini revealed that the storm's central temperature ranges between minus 150 degrees Celsius and minus 180 degrees Celsius, significantly lower than other areas of Saturn's atmosphere. The surrounding clouds contain methane, hydrogen, and ammonia, key components of Saturn's gaseous envelope. Laboratory simulations at Harvard University have shown that hexagonal shapes can naturally emerge when high-speed gas flows interact at specific angles. This hexagonal storm isn't just a physical phenomenon, but a masterpiece of the cosmos. It makes us feel small in the face of nature's boundless creativity. When you gaze at this perfect hexagonal structure, you can't help but wonder, is this a coincidence, or is nature trying to communicate a mathematical message? Imagine swirling a cup of hot coffee and noticing tiny geometric patterns forming in the liquid. On Saturn, this occurs on a colossal and far more complex scale. The stability of Saturn's hexagon reminds us that even in chaos, the universe hides its laws. NASA studies suggest that Saturn's strong gravity and rapid rotation help sustain these swirling gas streams, shaping the stable hexagonal structure. The storm's central eye rotates at slower speeds than the outer gas streams, creating pressure gradients and dynamics sufficient to sculpt this hexagonal marvel. This hexagon at Saturn's North Pole stands as a testament to the boundless creativity and diversity of nature. Unlike Earth's chaotic storms, Saturn presents a phenomenon whose beauty and complexity inspire both scientists and artists alike. From the hexagonal storm, we realize that Saturn's atmosphere is a highly dynamic and intricate system. But this is just the beginning. The periodic Great White Spots will take us further into understanding how Saturn operates as a massive weather empire. Have you ever wondered about storms so massive they could engulf an entire planet? On Saturn, approximately every 29 Earth years, a gigantic atmospheric phenomenon known as the Great White Spots emerges, far surpassing the scale and intensity of any storm we've ever encountered. These periodic giants dominate the planet's atmosphere, leaving scientists in awe and raising questions about the dynamics of weather in our universe. The Great White Spots on Saturn are unlike any weather phenomenon elsewhere. They occur cyclically every 29 Earth years, corresponding to one Saturnian year. This period marks significant atmospheric changes, particularly as Saturn moves closer to the Sun in its elliptical orbit. These superstorms begin deep within Saturn's atmosphere, where cold gases are forced upward to interact with hotter outer layers. The result is a massive explosion of water vapor and ammonia, forming the colossal white clouds visible from telescopes. They can last for months, covering Saturn entirely before dissipating. Studies from the Cassini spacecraft reveal that these storms can reach a diameter of 10,000 kilometers, roughly 80% of Earth's diameter. Wind speeds within these storms can reach up to 500 kilometers per hour, capable of annihilating any structure if they occurred on Earth. Cassini also found that the energy released by these storms is millions of times greater than that of an average hurricane on Earth. The Great White Spots are a testament to the creativity and power of the universe. They remind us of Earth's superstorms like Hurricane Katrina or Typhoon Haiyan, but on an exponentially larger scale. These storms are a vivid reminder of nature's unmatched ability to produce phenomena far beyond human comprehension. Imagine a hot summer day when water vapor rises from the ocean, forming enormous clouds that coalesce into a heavy downpour. On Saturn, this process occurs on a cosmic scale, with ammonia and methane gases creating colossal Great White Spots. This parallel suggests that even the universe's grandest phenomena share similarities with the everyday events we experience. NASA's research highlights that the Great White Spots extend far below the atmosphere, affecting Saturn's deeper layers, where pressure and temperature are immense. Observations from the Hubble Space Telescope show atmospheric changes preceding the storms, suggesting that they could be forecasted through early meteorological signals. Picture future spacecraft delving into these storms, gathering direct data and uncovering their mysteries. Such missions could herald a new era of understanding Saturn's atmosphere and its interconnected planetary weather systems. From the Great White Spots, we see that Saturn's atmosphere is far from static. It's a vibrant and dynamic system. Following this, we delve deeper into the planet's gaseous envelope, exploring the high-speed bands of gas that create a living, ever-changing mosaic of its weather dynamics. Have you ever imagined Saturn, famous for its majestic rings, hosting an atmosphere as dynamic as a never-ending symphony? With massive wind currents, vividly colored cloud bands, and powerful interactions between atmospheric layers, Saturn's atmosphere stands out as one of the most intriguing phenomena in the solar system. Saturn's atmosphere consists primarily of hydrogen, around 96%, and helium, around 4%, with traces of methane, ammonia, and other compounds. This mixture creates distinctive cloud bands, divided into different dynamic layers. Winds on Saturn can reach speeds of 1,800 kilometers per hour, faster than on any other planet in the solar system, playing a pivotal role in shaping its extraordinary atmospheric phenomena. These characteristics make Saturn's atmosphere an ever-moving system, constantly transforming and producing storms, vortices, and dramatic temperature variations. According to data from the Cassini spacecraft, Saturn's dynamic airflows form cloud vortex bands, thousands of kilometers long, moving parallel to its equator. Additionally, Cassini detected that Saturn's deeper atmospheric layers experience extreme temperature fluctuations, from minus 150 degrees Celsius in the upper atmosphere to 8,000 degrees Celsius at the core, fueling intense convection and providing energy for dynamic phenomena. These atmospheric features are not just scientific puzzles, but also an inspiration to reflect on the universe's constant motion. Saturn's atmosphere, with its interwoven streams and bands, resembles a natural dance, reminding us that even the seemingly most stable entities in the universe are in perpetual flux. Imagine a powerful river twisting and turning through mountains and plains, reshaping the landscape it flows through. Saturn's atmosphere is much like that, a colossal aerodynamic river enveloping the planet, continuously generating awe-inspiring phenomena and shaping the planet's surface features. According to NASA studies, Saturn spins incredibly fast, completing a full rotation in about 10.7 hours. This rapid rotation generates immense centrifugal forces, stretching Saturn's atmosphere horizontally and forming elongated cloud bands and constantly moving airflows. This phenomenon not only creates stunning visuals, but also offers valuable data on how gas giant planets operate. Saturn's atmosphere is not merely a part of the planet, but a vivid masterpiece. Its interwoven gas streams resemble brushstrokes on a constantly evolving canvas. Their unending motion evokes the feeling that the universe is a grand stage, and Saturn is one of its lead performers, delivering ceaseless, captivating shows. From the dynamic atmosphere, we see that Saturn is more than just a planet with beautiful rings. It is a world filled with extraordinary meteorological phenomena. This further feeds our curiosity about how atmospheres not only function, but also interact to create massive events like the Great White Spots, providing a comprehensive view of this vibrant planet. Have you ever thought that the shimmering rings surrounding Saturn, when seen through a telescope, are not a solid surface, but billions of ice and dust particles spinning at dizzying speeds? Saturn's rings are not just a beautiful symbol of the cosmos, but also hold secrets and valuable information about how planets and planetary systems are formed. Saturn's rings are made up of ice and rock particles of varying sizes, ranging from tiny grains like sand to chunks as large as a small truck. These particles are organized into separate bands such as A, B, C, and D, each with distinct properties and compositions. Notably, the ice particles within the rings strongly reflect sunlight, giving Saturn its radiant and easily recognizable appearance when observed from Earth. Furthermore, the rings are not continuous. They are separated by gaps like the Cassini division, a dark region devoid of material due to the gravitational influence of Saturn's moons. According to data from the Cassini spacecraft, Saturn's main rings span about 282,000 kilometers, but their average thickness is just 10 to 30 meters. This indicates that the rings are not only fragile, but also consist of a vast amount of loosely packed ice particles, enough to envelop this giant planet, like a delicate cosmic cloak. The sight of Saturn's rings leaves us awestruck and reminds us of nature's creativity. They are not merely a physical structure, but a living cosmic artwork. The translucent, glittering ice bands under the sun's light evoke a sense that even in the cold and desolate reaches of space, beauty always persists and shines. Imagine standing by a crystal-clear lake early in the morning, where sunlight creates sparkling reflections on the water's surface. Saturn's rings are similar, each ice particle reflecting light, coming together to form a breathtaking spectacle from afar. But instead of water, these reflections are created by ice, rock, and tiny dust particles. NASA scientists discovered that most of the ice particles in Saturn's rings contain up to 95% frozen water. This provides critical clues about the ring's origin, possibly formed from fragments of a moon or comet shattered by Saturn's immense gravity in the distant past. The structure of Saturn's rings is not just a lesson in how matter operates in space, but also a symbol of the complexity and harmony of the cosmos. These delicate bands persist, orbiting Saturn as a testament to how even in chaos, nature can create perfect beauty. By exploring the structure of the rings, we gain deeper insight into how planetary systems function. These bands are not merely a natural phenomenon, but also a bridge leading us to study the gravitational interactions between Saturn and its moons. The next puzzle piece in uncovering the mysteries of this giant planet.
Artlist.io.
Have you ever considered that one of the most iconic symbols of the cosmos, Saturn's rings, is only a temporary feature? The magnificent rings we admire through telescopes are not eternal. According to scientists, they are gradually disappearing, leaving a bare Saturn in the distant future. Saturn's rings have a very short lifespan compared to the planet's 4.5 billion years of history. Based on data from the Cassini spacecraft, the rings are being destroyed by a phenomenon known as ring rain, where ice and dust particles are pulled into Saturn's atmosphere by its strong gravity and solar radiation. This process not only reduces the mass of the rings, but also erases their stunning luminous appearance. It's estimated that the rings will last only about 100 to 300 million more years, a blink of an eye compared to the age of the planet. Scientists have observed significant rates of decay. Approximately 10,000 kilograms of material from the rings falls into Saturn's atmosphere every second. This stark figure illustrates how the rings are not just fading, but are being systematically dismantled year by year, century by century. The disappearance of Saturn's rings reminds us of the impermanence of everything in the universe. Even the grandest and most beautiful structures cannot endure forever. This realization makes us cherish the beauty of the cosmos even more, where everything has its own lifespan. Imagine cherry blossoms blooming in spring. They radiate beauty for just a few fleeting weeks before falling and leaving bare branches behind. Saturn's rings are similar, a transient beauty with profound significance, offering us unforgettable images and invaluable scientific knowledge. NASA's research suggests that the origin of the rings might trace back to a moon or comet shattered by Saturn's gravitational pull hundreds of millions of years ago. However, the ongoing ring rain is causing the ice particles to fall gradually, with no evidence indicating their regeneration in the future. The story of Saturn's rings' disappearance is not just an astronomical phenomenon, but also a reminder of the universe's ceaseless changes. Their beauty, though brief, leaves a lasting impression on those who love science and exploration. From the fading of Saturn's rings, we are inspired to delve deeper into their connection with Saturn and its moons, opening up new questions and directions in the endless journey of space exploration. Have you ever considered that the small moons orbiting Saturn are not merely silent companions but crucial players in the formation, maintenance, and even destruction of its magnificent rings? The gravitational interactions between Saturn, its moons, and the surrounding bands of material are not just a matter of physics, but a complex and harmonious story of cosmic orchestration. Saturn's moons, from large ones like Titan and Enceladus to smaller ones like Mimas, not only feel the gravitational pull of Saturn, but also influence its rings in return. These moons create gaps in the ring system, such as the Cassini division, formed by Mimas's gravitational pull. These interactions generate a gravitational resonance effect that has maintained the structure and stability of the rings for millions of years. In addition to creating gaps, some moons also contribute material to the rings. Enceladus, with its icy plumes from an underground ocean, supplies significant amounts of ice to the E-ring, one of the faintest yet critically important rings for maintaining the overall balance of the system. According to data from the Cassini spacecraft, the interactions between the moons and rings are ongoing, with measurable shifts in the orbits of ice particles. Smaller moons, often referred to as shepherd moons, help keep ice particles from spreading outward, ensuring the rings remain as stable as possible. The interaction between the moons and rings evokes a sense of interconnection and mutual dependence in the cosmos. It's like a symphony where each moon is an instrument, working in perfect harmony to produce a flawless performance. This leaves us in awe of the complexity and meticulous organization of nature. Imagine a train system where each carriage is linked and influenced by the one before and after it. On Saturn, the moons act as the lead carriages, shaping and stabilizing the ring train as it orbits harmoniously around the planet. NASA estimates that the orbits of major moons like Enceladus can shift the positions of ring particles in the E-ring by 5 to 10% within a century. These figures highlight how the stability of the ring system relies heavily on the gravitational relationships between the elements in space. Gravitational interactions are not merely a physics problem, but a testament to nature's harmony. The universe is not a chaotic void, but a place where every element is interconnected, dependent, and influences one another in ways that are breathtakingly precise. From these gravitational interactions, we can expand our understanding of how gravity shapes planets, moons, and planetary systems across the universe. This is also the key to unlocking deeper secrets about the workings of Saturn and other planets in the solar system. Titan, the moon, with a unique atmosphere. Have you ever imagined that a small moon more than 1 billion kilometers away from Earth could have a dense atmosphere with striking similarities to our own planet? Titan, Saturn's largest moon, is not just a cold, desolate rock, but a mysterious world with methane weather cycles, massive lakes, and the potential to harbor life. Titan's atmosphere is a unique phenomenon in the solar system. It is the only known moon with a thick atmosphere composed primarily of nitrogen, 95%, similar to Earth's atmosphere. Intriguingly, it also contains methane and hydrocarbon compounds, creating a weather cycle that is eerily similar to Earth's water cycle. On Titan, methane replaces water, evaporating, condensing, and forming rain that fills the lakes and seas of liquid methane on its surface. The average temperature on Titan is -179 degrees Celsius, cold enough for methane to exist in liquid form, making it one of the most promising candidates for studying the potential for extraterrestrial life. Data from the Cassini and Huygens spacecraft reveal that Titan's surface is covered by the largest methane lakes in the solar system, such as Kraken Mare, which is larger than the Caspian Sea on Earth. These lakes not only provide a unique chemical environment, but also store energy that could support life under extreme conditions. When we look at images of Titan, we are awed by the complexity and creativity of the universe. A small moon, yet brimming with the characteristics of a vibrant world, where natural phenomena such as rain, rivers, and lakes occur just like on Earth, but with methane instead of water. Imagine standing on the shore of a lake, watching gentle waves lap against the sand. On Titan, a similar scene unfolds, but instead of water, it's liquid methane. A surreal and poetic vision of an alien world. According to NASA's research, the amount of methane in Titan's lakes could supply energy for Earth's civilization for millions of years. This not only provides scientific value, but also hints at future potential for resource utilization. Titan is not just a moon, it's a miniature planet, a natural laboratory for scientists to study the origins and possibilities of life. Every feature on Titan reminds us that the universe holds countless wonders waiting to be discovered. From Titan's unique atmosphere, we see that the solar system may have more than one place capable of supporting life. Titan opens a new chapter in the search for extraterrestrial life, while leading us to the next mystery, the hidden oceans of Enceladus. Enceladus, the subsurface ocean and potential for life. Have you ever imagined that beneath the icy surface of a small moon, orbiting Saturn, lies a vast subsurface ocean containing all the essential ingredients for life? Enceladus, seemingly barren on the outside, is now one of the most promising candidates in the search for extraterrestrial life. Enceladus's surface is covered by a thick ice shell, but observations from the Cassini spacecraft revealed an incredible secret. Beneath this ice lies a vast subsurface ocean, kept in liquid form by tidal heating from Saturn's gravitational pull. The towering plumes of ice, shooting hundreds of kilometers into space from the moon's south pole, contain water, methane, and various organic compounds, all vital ingredients for life. The presence of hydrogen in these plumes is a clear signal of chemical reactions similar to those found in hydrothermal systems at the bottom of Earth's oceans. Studies suggest that the subsurface ocean on Enceladus is about 10 kilometers deep and protected by an ice shell 20 to 30 kilometers thick. Data from Cassini indicates that heat generated by tidal friction keeps the water in liquid form, offering a potential environment for microorganisms to thrive in conditions similar to Earth's extreme ecosystems. These findings are not just dry scientific data, but also ignite hope for the possibility of life beyond Earth. A small, seemingly silent world could hold untold stories of life, inspiring not only scientists, but also everyone who yearns to uncover the secrets of the cosmos. Imagine standing beside a hot spring where steam rises from the Earth, carrying life and energy. On Enceladus, a similar phenomenon occurs, but on a much grander scale and under harsher conditions. It is proof that even the most remote corners of the universe might harbor life. According to NASA, the organic compounds found in the icy plumes could indicate the presence of microorganisms living beneath the ocean. Hydrogen, a crucial energy source for life on Earth, is present in significant amounts, underscoring Enceladus's potential as a habitat for life based on chemosynthesis. Enceladus is not just a small moon. It is a gateway bringing humanity closer to answering the great question: are we alone in the universe? With its subsurface ocean and potential for life, Enceladus exemplifies the resilience of life in seemingly uninhabitable conditions. These discoveries show that the universe is a place full of mysteries and surprises. Enceladus's subsurface ocean is not only a wonder, but also an invitation for humanity to continue its journey of exploration. seeking to understand life and our place in the cosmos. Exploring further through future missions. Have you ever wondered, if we could reach Titan or Enceladus, could we finally answer the mysteries of extraterrestrial life? These moons are not just research targets, but keys to unlocking a new era of space exploration, with upcoming missions promising groundbreaking discoveries. Future missions are being planned to delve deeper into Titan and Enceladus, two of Saturn's moons with the potential to harbor life. One standout project is Dragonfly, scheduled to launch to Titan in 2027. This advanced flying vehicle will traverse Titan's surface, studying methane lakes, analyzing soil samples, and searching for complex organic compounds. Meanwhile, the proposed Enceladus Life Finder ELF mission aims to explore Enceladus's icy plumes, searching for microbial life and identifying chemical compounds capable of supporting life. These missions not only aim to enhance our understanding of these moons, but also lay the groundwork for exploring other planetary systems in the universe. According to NASA, Dragonfly will focus on investigating Titan's chemical environment, particularly prebiotic molecules in its atmosphere and surface. Advanced analytical equipment will help determine whether Titan has the necessary conditions to support life. Similarly, ELF is expected to use cutting-edge sensors to collect data from Enceladus's plumes, where organic compounds and liquid water have already been detected. These missions are not just scientific endeavors, but also ignite humanity's curiosity and desire to explore. Imagine a flying vehicle soaring over Titan's skies, or a spacecraft approaching Enceladus's icy plumes. These images embody not only science, but also the human dream of reaching further. Picture yourself as an explorer standing on Titan's surface, where faint sunlight filters through a thick atmosphere, or gazing at the towering ice plumes of Enceladus. It's a feeling of both unfamiliarity and exhilaration, where scientific discovery meets humanity's instinct for conquest. Data from current missions have already revealed Titan and Enceladus's immense potential. According to NASA, the organic compounds found on these moons are not just chemical substances, but crucial pieces of the puzzle in understanding the origins of life. Every step forward in space exploration is a testament to humanity's relentless spirit. Dragonfly and ELF represent not only technological advancements, but also a promise for the future, where the mysteries of extraterrestrial life will gradually unfold. From Titan and Enceladus, we seek not only signs of life, but also a broader understanding of the universe and ourselves. These missions are not just about answering the question, "Are we alone?" but also about embarking on new journeys that push humanity further in its quest to explore the cosmos. What happens when a planet doesn't spin upright like most others, but lies nearly flat on its orbital plane? This is the peculiar reality of Uranus, a planet tilted at 98 degrees. This extreme angle makes Uranus's operation extraordinarily unique, resulting in decades-long seasons and extreme weather phenomena unparalleled in the solar system. Uranus, the seventh planet from the Sun, is nicknamed the Sideways Planet due to its nearly horizontal rotation axis. While most planets, such as Earth with its 23.5-degree tilt, spin with only a slight inclination, Uranus rotates at an extraordinary 98-degree tilt. This peculiar orientation causes the planet to roll around the Sun like a ball on a table, rather than spinning upright. As a result, one hemisphere faces the Sun continuously for 21 years, while the other hemisphere remains shrouded in cold darkness. This is more than just a physical anomaly. It significantly influences the planet's natural phenomena, from its climate to its magnetic field. Scientists believe this unique tilt is the result of a cosmic collision during the solar system's formation, making Uranus fundamentally distinct from any other planet. Data from Voyager 2 reveals that this tilt causes Uranus's magnetic field to be offset by as much as 59 degrees from its rotational axis. This creates an asymmetric magnetic field, resulting in phenomena such as uneven auroras between the two hemispheres. Moreover, wind speeds on Uranus can reach a staggering 900 kilometers per hour, generating intense and divergent atmospheric currents. These findings not only highlight the planet's strangeness, but also raise profound questions about its collision history. Uranus's uniqueness inspires awe and admiration for the richness of the cosmos. Each planet, no matter how peculiar, exists in its own way. Uranus is a testament to the fact that the universe has no fixed standards and is full of surprises and wonders. Imagine if Earth had Uranus's tilt. The Arctic might be bathed in sunlight for 21 years, while the Antarctic remains in perpetual darkness. Such conditions would upend ecosystems and lead to harsh climate changes. This is the reality on Uranus, a vivid example of how diverse planetary systems can be. A NASA study suggests that this unusual tilt may have resulted from a colossal collision with an Earth-sized celestial body during the early stages of the solar system. This impact not only drastically altered Uranus's axis, but also deeply affected its core structure and magnetic field. It also explains why Uranus's atmosphere experiences far greater turbulence compared to other ice giants. If Uranus were personified, it would symbolize individuality and uniqueness in the solar system. It doesn't spin like any other planet, but that very difference makes it remarkable and compelling. Its 98-degree tilt is more than a physical feature. It's a narrative of an event that shaped the planet billions of years ago. The tilt of Uranus influences not only its day-night cycle or seasons, but also creates unique phenomena unseen on any other planet. Understanding the cause and effects of this feature will enable scientists to delve deeper into the planet's history and broaden our understanding of how planetary systems operate across the universe. Have you ever wondered how a planet could end up spinning on its side in the solar system? The story of Uranus offers a compelling possibility, a massive cosmic collision that changed the way this planet operates forever. This is one of the most intriguing hypotheses explaining its extraordinary 98-degree tilt. One of the most convincing theories about Uranus's peculiar tilt is that it was caused by a massive impact with a large celestial body during the early stages of the solar system, approximately 4 billion years ago. Scientists suggest that a body similar in size to or larger than Earth collided with Uranus at an incredibly high speed, tilting the planet's axis almost parallel to its orbital plane. This catastrophic event not only altered Uranus's rotation, but also left a profound impact on its magnetic field, atmosphere, and core structure. Simulations conducted by researchers at Durham University strongly support this hypothesis, showing that only such a powerful collision could produce the extreme tilt observed today. Data from NASA indicates that Uranus's magnetic field is offset by as much as 59 degrees from its rotational axis, an unusual feature among planets in the solar system. This suggests that the impact disrupted not only the surface, but also the internal structure of Uranus, causing its core and magnetic field to become misaligned. Additionally, the planet's atmosphere shows peculiar characteristics, such as asymmetric wind patterns between its two hemispheres. The story of Uranus is not just a physical phenomenon, but a reminder that the universe rarely operates the way we expect. The image of a planet impacted by a catastrophic event, yet maintaining its balance, is a vivid demonstration of nature's resilience. It inspires us to see that no matter how great the disruption, the cosmos continues to evolve in its own unique way. Imagine a bowling ball struck by a larger object with enough force to knock it completely off its axis. This is perhaps the most relatable analogy for what happened to Uranus. The collision not only altered its orbit, but redefined the planet's very nature. Simulations from supercomputers at the University of Zurich suggest that the impact involved a body twice the mass of the Moon, traveling at over 15 kilometers per second. The energy released in the collision was enough to partially melt Uranus's interior layers, contributing to its off-center core structure. These findings further reinforce the hypothesis of a massive collision. The tale of Uranus's collision is like an unexpected chapter in the universe's grand narrative. It challenges our imagination and offers fresh perspectives on how planets form and evolve. Uranus's 98-degree tilt is not a random anomaly, but a testament to its tumultuous history. This collision shaped the way Uranus exists in the cosmos, but its effects extend beyond the tilt. The impact has led to peculiar climate and magnetic phenomena, which remain topics of continued exploration in future studies about this fascinating planet. What if every season on Earth lasted for 21 years? This isn't science fiction. It's the reality of Uranus. The planet's unique 98-degree axial tilt creates extraordinarily long seasons, leading to unprecedented climate dynamics in the solar system. The extreme tilt of Uranus results in seasons that last approximately 21 Earth years in each hemisphere. When one hemisphere faces the Sun, it is bathed in continuous sunlight for a quarter of its orbital period, 21 Earth years. Meanwhile, the other hemisphere is plunged into darkness, enduring extreme cold. This creates significant temperature differences between the two hemispheres, destabilizing Uranus's atmosphere. Weather phenomena, such as migrating methane clouds, often emerge at the boundary between the hemispheres during seasonal transitions. This makes Uranus one of the most complex weather systems in the solar system. Data from Voyager 2 and modern telescopes reveal that temperatures on Uranus range from -224 degrees Celsius in dark regions to -200 degrees Celsius in sunlit areas. This temperature disparity generates high-speed winds, reaching up to 900 kilometers per hour, driving powerful atmospheric currents. These currents not only disrupt the atmosphere, but also influence the structure of clouds and the planet's magnetic activity. The extended weather cycles on Uranus remind us of the remarkable diversity of planets in the solar system. While Earth enjoys short, stable seasons, Uranus is a striking example of how a slight physical change can trigger a chain reaction with massive effects on a planet's climate system. Imagine a summer that lasts 21 years, with one half of the planet scorched by sunlight, while the other half is engulfed in freezing darkness. Similarly, the phenomenon of prolonged day and night in Earth's polar regions is the closest analogy to Uranus's seasons, but on a much larger and harsher scale. Observations from the Hubble Space Telescope indicate that during seasonal transitions, Uranus's atmosphere exhibits methane hotspots, where temperatures spike higher than surrounding areas. Scientists have noted that these hotspots persist throughout the transition period, creating an extended phase of extreme weather. If the seasons on Uranus were a story, they would be one of constant transformation. Each phase brings about significant changes in the climate system, making the planet a perfect natural laboratory for studying atmospheric and weather dynamics. The prolonged seasons on Uranus are not only a result of its axial tilt, but are also tied to its magnetic structure and complex atmospheric dynamics. These phenomena remain a subject of extensive research, promising new insights into how ice giants like Uranus operate within the solar system. Why does Uranus stand out with its pale blue hue amidst the dark canvas of space? The answer lies deep within its atmospheric composition. where unique gases interact to craft this mesmerizing and distinctive appearance. This is not merely about color, but also a journey to uncover the extraordinary features of one of the coldest planets in the solar system. Uranus's atmosphere primarily consists of three key components: hydrogen, approximately 82%, helium, 15%. Despite its small concentration, methane plays a pivotal role in defining the planet's color. Methane absorbs red light from the sun and reflects blue light, making Uranus resemble a giant aquamarine gemstone in space. Beyond its visual appeal, Uranus's atmosphere stands out for its uneven distribution of gases and extremely low temperatures, -224 degrees Celsius, creating a complex and dynamic environment. Studies reveal thin methane cloud layers in the upper atmosphere, interacting with strong winds to produce unique climatic phenomena. Data from Voyager 2 indicates that the outermost atmospheric layer of Uranus has the lowest temperatures in the solar system, dropping to -224 degrees Celsius. Observations from the Hubble telescope further highlight that methane acts as a natural light filter, absorbing most red and orange wavelengths while leaving pale blue light to reflect into space. The uniqueness of Uranus's atmosphere reminds us that beauty lies not in perfection, but in distinctiveness. The planet, with its gentle pale blue, evokes a sense of serenity amidst cosmic chaos, while simultaneously inviting humanity to uncover its hidden secrets. Imagine a crystal-clear glass reflecting sunlight. The rays of light refracting through the glass create a shimmering spectrum, much like how methane in Uranus's atmosphere interacts with sunlight to produce its pale blue hue. This simple analogy offers a tangible way to grasp the planet's enigmatic charm. Recent observations from the JWST reveal that slight seasonal variations in methane concentrations can cause subtle shifts in Uranus's color, showcasing the intricate interplay between its atmospheric factors and solar radiation. If the planets in the solar system were characters in a grand narrative, Uranus would undoubtedly be the one with mysterious inner beauty. Without dazzling lights or elaborate structures, its pale blue simplicity tells a profound story of its formation and evolution. The atmosphere of Uranus is not merely an aesthetic feature, but a gateway to deeper insights into its interaction with the cosmic environment. The presence of powerful winds and frigid temperatures sets the stage for exploring more climatic phenomena, which will be analyzed in subsequent sections. How can a small concentration of methane in the atmosphere influence both the color and weather of Uranus? This is not just a story about light and color, but also the key to unlocking the mysteries of strange climatic phenomena and massive storms on this icy planet. Methane, one of the primary components of Uranus's atmosphere, plays a crucial role in creating its pale blue color. Methane absorbs red sunlight and reflects blue light, making the planet stand out with its unique beauty in the dark vastness of space. However, methane's role extends beyond its coloration to a completely different realm of weather phenomena. In the frigid atmosphere of Uranus, methane interacts with powerful wind currents and extreme temperatures to form massive cloud systems and mobile storms. These storms typically occur in the upper atmosphere, where low pressure meets high-speed winds, generating complex and unstable weather patterns. According to data from Voyager 2, methane storms can move at wind speeds of up to 900 kilometers per hour, far surpassing most storms on Earth. Scientists have observed enormous methane clouds stretching thousands of kilometers, moving between hemispheres with seasonal shifts. This characteristic not only highlights the dynamism of Uranus's atmosphere, but also raises intriguing questions about how its gaseous components interact to maintain equilibrium in such harsh conditions. The presence of methane storms on Uranus strongly indicates that even in the coldest and most distant regions, nature operates with surprising power and energy. The planet resembles an endless dance, where gas and light combine to create a symphony of motion and transformation. Imagine a tropical storm on Earth, where clouds and water combine to generate strong air currents. Similarly, the methane storms on Uranus, though devoid of water, exhibit immense power thanks to the combination of methane gas and frigid temperatures. This analogy offers a relatable perspective on how extreme weather can occur on other planets. Recent studies from the Hubble Space Telescope reveal that methane storms can persist for decades, continually changing in size and shape. The appearance of dense methane clouds during the summer of each hemisphere is a climatic highlight, providing valuable insights into the planet's dynamic processes. If the methane storms on Uranus were pieces of art, they would be a testament to nature's boundless creativity. Without water or heat, this planet still manages to produce grand and awe-inspiring weather phenomena. Methane not only shapes the color of Uranus, but also injects dynamism into its atmosphere. Understanding methane's role will help us explore other mysterious climatic phenomena, from auroras to high-speed winds, which will be analyzed in subsequent sections. How can a small concentration of methane in the atmosphere influence both the color and weather of Uranus? This is not just a story about light and color, but also the key to unlocking the mysteries of strange climatic phenomena and massive storms on this icy planet. Methane, one of the primary components of Uranus's atmosphere, plays a crucial role in creating its pale blue color. Methane absorbs red sunlight and reflects blue light, making the planet stand out with its unique beauty in the dark vastness of space. However, methane's role extends beyond its coloration to a completely different realm of weather phenomena. In the frigid atmosphere of Uranus, methane interacts with powerful wind currents and extreme temperatures to form massive cloud systems and mobile storms. These storms typically occur in the upper atmosphere, where low pressure meets high-speed winds, generating complex and unstable weather patterns. According to data from Voyager 2, methane storms can move at wind speeds of up to 900 kilometers per hour, far surpassing most storms on Earth. Scientists have observed enormous methane clouds stretching thousands of kilometers, moving between hemispheres with seasonal shifts. This characteristic not only highlights the dynamism of Uranus's atmosphere, but also raises intriguing questions about how its gaseous components interact to maintain equilibrium in such harsh conditions. The presence of methane storms on Uranus strongly indicates that even in the coldest and most distant regions, nature operates with surprising power and energy. The planet resembles an endless dance, where gas and light combine to create a symphony of motion and transformation. Imagine a tropical storm on Earth, where clouds and water combine to generate strong air currents. Similarly, the methane storms on Uranus, though devoid of water, exhibit immense power thanks to the combination of methane gas and frigid temperatures. This analogy offers a relatable perspective on how extreme weather can occur on other planets. Recent studies from the Hubble Space Telescope reveal that methane storms can persist for decades, continually changing in size and shape. The appearance of dense methane clouds during the summer of each hemisphere is a climatic highlight, providing valuable insights into the planet's dynamic processes. If the methane storms on Uranus were pieces of art, they would be a testament to nature's boundless creativity. Without water or heat, this planet still manages to produce grand and awe-inspiring weather phenomena. Methane not only shapes the color of Uranus, but also injects dynamism into its atmosphere. Understanding methane's role will help us explore other mysterious climatic phenomena, from auroras to high-speed winds. which will be analyzed in subsequent sections. Have you ever imagined that auroras, the familiar brilliant lights of Earth's skies, also exist on Uranus, but in a completely different form? On Uranus, auroras are not just ordinary light displays, but shine brightly in the infrared spectrum, unveiling an entirely new world of interaction between magnetic fields and cosmic energy. Auroras on Uranus result from the interaction between its unusual magnetic field and solar wind. Unlike Earth, where the magnetic field is nearly aligned with its rotational axis, Uranus's magnetic field tilts at an angle of 59 degrees relative to its rotation. This misalignment creates an asymmetric and unevenly distributed magnetic system. When charged particles from the solar wind collide with Uranus's atmosphere, they excite gas molecules, producing auroras not only at the poles, but also across various regions of the planet. What sets these auroras apart is their strong emission in the infrared spectrum, a phenomenon unseen on other planets in the solar system. According to Voyager 2 data, infrared auroras on Uranus are formed when high-energy electrons from the solar wind interact with gas molecules, primarily hydrogen, in the planet's atmosphere. This not only illuminates the sky, but also reveals critical details about how Uranus's magnetic field and atmosphere operate. Scientists have observed that these auroras intensify as the planet moves closer to its anti-solar point, where the solar wind's impact is strongest. Auroras on Uranus are not just a cosmic wonder, but also a reminder of nature's boundless creativity. Despite its distance and icy environment, the planet finds a way to showcase its unique beauty, reminding us that the universe is always brimming with undiscovered marvels. Imagine Earth's night sky aglow with streaks of green, red, and purple auroras. On Uranus, this phenomenon is reimagined in the infrared spectrum, creating a light show invisible to the naked eye. It's a spectacle that can only be captured through advanced technology, but is no less mesmerizing in its allure. Space telescopes like Hubble and JWST have observed that Uranus's infrared auroras can last for several hours, varying in intensity with the solar wind's activity cycles. These findings not only provide insights into the planet's magnetic dynamics, but also open new avenues for exploring the interaction between cosmic energy and planetary environments. If auroras on Uranus were a symphony, they would be composed of light and cosmic energy, each note bearing the planet's unique signature. This phenomenon enriches humanity's understanding of the cosmos and serves as an endless source of inspiration for generations of scientists. The infrared auroras of Uranus are not just a physical phenomenon, but a gateway to deeper insights into the planet's nature. Its distinct magnetic and atmospheric characteristics promise many more astonishing discoveries in future research. Did you know that Uranus also has rings like Saturn? But instead of being bright and expansive, these rings are dim and narrow. Their quiet beauty is a testament to the diversity of how the universe expresses itself. This is not just a physical feature, but a profound story of the planet's icy nature and formation. Uranus's rings consist of 13 narrow bands, with the primary rings composed of dust and ice particles ranging in size from fine grains to boulder-sized chunks. These rings are characterized by their dark coloration and low visibility, starkly contrasting Saturn's brilliant rings. Scientists first discovered them in 1977 through a stellar occultation event, when a star behind Uranus dimmed as the planet and its rings passed in front. The thinness and small particle size make these rings reflect very little light, rendering them almost invisible to conventional observation tools. Data from Voyager 2 revealed that Uranus's ring system is not merely a fragile structure, but a dynamic and intricate one. Research from the Hubble telescope suggests that these rings are stabilized by nearby small moons, acting as shepherds to prevent particle dispersion. This gravitational interaction keeps the rings tightly bound, despite the planet's relatively weak gravitational field. The existence of these dim rings amazes us with the diversity of planetary features in the solar system. They may not sparkle like Saturn's, but they hold a mysterious beauty, reminding us that sometimes magnificence lies in the unobservable. The rings of Uranus exemplify the subtlety in how the universe crafts planetary systems, where even the smallest details carry significant meaning. Imagine a bracelet made of faint dust particles orbiting an icy gemstone in the vastness of space. This unassuming band may not stand out, but its presence is an essential part of the whole picture. This analogy perfectly encapsulates Uranus's ring system. Recent observations from the James Webb Space Telescope reveal that these rings are not static structures, but may undergo slight changes over time. These fluctuations are believed to result from gravitational interactions with nearby moons and the influence of solar wind, providing deeper insights into the behavior of matter in space. If the rings of Uranus were gentle notes in the symphony of the cosmos, they would be the soft bass tones, providing balance to the harmony of icy planets. These rings are not just part of the planet, they are key to understanding how matter coalesces and evolves in the universe. Though dim and subtle, Uranus's rings contain stories about the formation and evolution of the planet. They serve as a gateway to exploring complex dynamics, directly connecting to the Moon system and other gravitational phenomena unique to this icy world. Miranda and Ariel, two of Uranus's largest moons, are not just quiet celestial bodies orbiting in isolation. They carry stories of formation and evolution, and play a vital role in shaping and maintaining Uranus's ring system. What makes them such captivating objects of study in planetary science? Miranda is known as one of the strangest moons in the solar system due to its rich geological features, including enormous cliffs and icy plains. Some regions on Miranda exhibit altitude differences of up to 20 kilometers, with Verona Rupes considered one of the tallest cliffs in the solar system. Ariel, on the other hand, stands out with deep fissures and icy plains sculpted by ancient geological activity. Ariel's surface suggests evidence of ice flows, possibly driven by temporary internal heating. These geological characteristics not only enhance the allure of the moons, but also reveal their gravitational interactions with Uranus's ring system. According to Voyager 2 data, the gravitational pull of Miranda and Ariel significantly influences the icy and dusty particles within Uranus's rings, helping maintain their narrow and stable structure. NASA studies indicate that this gravitational resonance creates gaps and dense regions within the rings, much like Saturn's moons interact with its expansive ring system. The imagery of Miranda and Ariel evokes a sense of mystery. They are like finely carved gemstones, each geological feature narrating a story of how gravity and natural forces combined to create a harmonious yet complex system. Imagine Miranda as a precious gem with deeply etched lines, and Ariel as a massive frozen river sculpted over billions of years. Each moon is not only part of Uranus, but also a cosmic masterpiece, a testament to the power of time and gravity. Observations from the Hubble telescope reveal that Miranda and Ariel may contain water in the form of ice, raising the possibility that they once harbored or still maintain subsurface oceans. These findings pose larger questions about the potential for life and the interplay between geological and dynamical factors in Uranus's system. If Miranda and Ariel were artists, they would be creators who shaped their surroundings with natural strength and creativity. Their existence and characteristics are not only visually captivating, but also scientifically invaluable, providing insights into how Uranus's system operates. With their remarkable geological features, Miranda and Ariel are not only stabilizing forces for Uranus's rings, but also beacons for future research. They are gateways to deeper exploration of how the universe forms and evolves. Have you ever wondered if the mysteries of Uranus will finally be unraveled in the future? An icy planet with dim rings and enigmatic moons, Uranus continuously challenges our understanding of the cosmos. Now, the Uranus Orbiter mission, a bold and ambitious project, promises to unlock new doors in our quest to understand its intricate system of rings and moons. Proposed by NASA, the Uranus Orbiter mission is expected to launch in the 2030s, with the primary goal of exploring Uranus's rings and moons in detail. The spacecraft will carry advanced scientific instruments to gather data on the chemical composition, dynamics, and atmospheric phenomena of the planet. One of the mission's key objectives is to map major moons such as Miranda and Ariel while analyzing the structure and interactions of Uranus's rings. This project not only expands our understanding of Uranus, but also enables comparisons with other gas and ice giants like Saturn and Neptune to identify similarities and differences. According to NASA reports, the Uranus orbiter will conduct precise measurements of the planet's gravitational forces, magnetic field, and atmospheric composition. Infrared spectroscopy and radar instruments will examine the icy surfaces of the moons, revealing geological features and the potential existence of subsurface oceans. These data are crucial for understanding the formation and evolution of ice giants in the solar system. Preparing for a mission like Uranus Orbiter is not just a scientific challenge, but also a profound source of inspiration. It demonstrates humanity's resolve to conquer distant planets, pushing the boundaries of knowledge to uncover the unknown. This mission is not just about Uranus, but also a testament to the unyielding spirit of exploration. Imagine a day when detailed images of moons like Miranda and Ariel, their icy terrains, and data on the composition of Uranus's rings are transmitted back to Earth. These aren't just pictures, but treasures of knowledge that expand our perspective of the cosmos. A recent study from the Space Science Institute highlights that deeper exploration of Uranus's moons may reveal signs of liquid water and organic compounds, essential components for life. This represents a significant milestone in the search for extraterrestrial life, a goal the Uranus Orbiter mission could help achieve. If the Uranus Orbiter mission were an explorer, it would be a ship carrying humanity's aspirations, crossing vast distances to decode the greatest mysteries of this icy world. Beyond data collection, it embodies humanity's hopes and ambitions for a future where the universe is no longer a mystery. The Uranus Orbiter is not just a scientific endeavor, but a symbol of human progress in understanding the cosmos. Its discoveries will not only expand our knowledge, but also drive technological advancements and inspire future generations. Exploring the South Pole of the Moon. South Pole, a special region containing permanently shadowed craters, where sunlight never reaches. Imagine standing in a land where sunlight never touches the ground. A place where darkness is eternal, where there is no day or night. This is the reality of the permanently shadowed craters at the South Pole of the Moon, one of the most mysterious regions of our celestial neighbor. But why do such regions exist on the Moon? And how important are they for humanity's exploration? The South Pole of the Moon is home to permanently shadowed craters, which are located deep within large lunar basins and are permanently out of reach of sunlight due to the tilt of the Moon's axis and its rotation dynamics. As a result, these regions maintain extremely low temperatures, dropping to about -250 degrees Celsius, conditions cold enough to preserve water ice for billions of years without it melting. For scientists, these craters are not only natural wonders, but also treasures containing valuable clues about the Moon's history and the solar system's formation. With water ice potentially existing in these craters, scientists hope that these areas may contain important records of past astronomical events, from meteor impacts to climatic shifts. Studying these shadowed craters will not only help us understand the Moon's history, but also provide insights into the formation of planets in our solar system. Furthermore, if water is indeed present, it could become a critical resource for future space missions. Data from NASA's Lunar Reconnaissance Orbiter, LRO, has confirmed that the permanently shadowed craters at the Moon's south pole span an area of approximately 20,000 square kilometers. Studies on the hydrogen content in these areas indicate a high likelihood of ice water being present, with estimates of millions of tons of water potentially stored there. When looking at these craters, we don't just see a cold and barren landscape. We see a priceless opportunity, an opportunity to expand our knowledge and explore the secrets the universe has kept hidden for millions of years. This is a magical adventure that only the most curious explorers will embark on. Imagine an archaeologist finding ancient pottery in the darkest part of a tomb. These pots have remained intact because the cold and dark conditions have preserved them over centuries. The permanently shadowed craters on the Moon might hold similar cosmic artifacts, preserving irreplaceable records of the past. NASA scientists have studied over 2,000 shadowed craters on the Moon, with approximately 15% showing high levels of water content. This ongoing research aims to explore the scientific and practical potentials of these regions for future space missions. These permanently shadowed craters are not mere geological features. They are like cosmic vaults, keeping the universe's secrets safe from the light of day. These craters resemble cosmic tombs, guarding what has passed, yet simultaneously offering the opportunity for those brave enough to peer into the darkness and discover what remains unknown. By exploring these permanently shadowed craters, Chandrayaan-3 has opened a new chapter in lunar exploration. These findings will lay the groundwork for further research into other shadowed regions on planets and moons, particularly regarding the existence of water in the universe. Could the Moon become a home for future space missions? We will find out in upcoming studies. South Pole, rugged terrain with high cliffs and deep craters, creating challenges for landing. Have you ever wondered what makes landing at the Moon's South Pole so challenging? It's not the distance or the lack of an atmosphere, it's the rugged terrain with towering cliffs and deep craters. This is not just a technical puzzle, it's a battle against the unforgiving natural forces of the universe. The South Pole of the Moon is considered one of the most complex terrains scientists have ever encountered. Craters like Shackleton, Amundsen, and Haworth are not only vast in diameter, but also plunge to depths of several kilometers. Steep slopes, combined with towering cliffs, create daunting obstacles for any landing vehicle. Sunlight barely reaches many parts of this region, leading to permanently shadowed areas that further complicate the task of pinpointing a safe landing site. With this mix of rugged terrain and limited light, landing safely in this region requires the most advanced technology and calculations down to the millimeter. According to data from the Lunar Reconnaissance Orbiter, Shackleton Crater alone is nearly 4.2 kilometers deep, with an average slope of around 30%. These numbers pose a significant risk of losing control for any lander without precise programming. Chandrayaan-3 overcame this challenge using advanced navigation systems that combined radar and real-time terrain scanning cameras, enabling it to land with remarkable accuracy. Imagine being an explorer facing towering cliffs and deep craters, where one misstep could spell disaster. Yet, these challenges highlight human courage and capability. Conquering such terrains is not only a technological achievement, but also a symbol of humanity's relentless desire to overcome the impossible. To visualize this, think of mountaineers scaling Everest. They face rocky cliffs and icy slopes, requiring patience, skill, and cutting-edge tools to tackle harsh conditions. Landing at the Moon's South Pole is much the same. Every step is fraught with risk, but the rewards unlock new realms of knowledge. Data from missions like Chandrayaan-3 show that to land in such terrain, landing systems must be programmed to handle slopes and dynamically balance with a precision of just about 10 centimeters. This breakthrough in aerospace technology demonstrates our ability to handle intricate challenges in extreme environments. The rugged terrain of the South Pole doesn't just make landing difficult, it opens up opportunities to uncover mysteries we've never been able to reach before. In places that seem impossible to access, human persistence and ingenuity shine brightest. These deep craters are not just filled with darkness, but also hold the light of knowledge waiting to be uncovered. Chandrayaan-3's success at the South Pole is not just a milestone in space exploration, but an invitation for future missions. Other areas of the Moon and planets beyond are waiting to be explored, where rugged terrains will continue to be our adversary and a source of endless inspiration for humanity. Chandrayaan-3, a milestone landing that opens new frontiers for lunar science. On August 23, 2023, a historic event unfolded. India's Chandrayaan-3 successfully landed at the Moon's South Pole, a region shrouded in eternal darkness. This achievement not only solidified India's position in the space exploration arena, but also opened the door to groundbreaking scientific discoveries about our closest celestial neighbor. Why is this region so important? And what did Chandrayaan-3 accomplish through its success? The success of Chandrayaan-3 is not merely a technological milestone, but also a breakthrough in science. The Moon's South Pole, with its permanently shadowed craters and rugged terrain, has long been a dream destination for scientists worldwide. Landing here required utmost precision and cutting-edge technology. Equipped with the Vikram lander and Pragyan rover, Chandrayaan-3 was designed to withstand harsh conditions and collect critical data. After landing, it undertook several key missions, including analyzing the lunar soil, searching for traces of water ice, and studying the thin atmosphere in this region. These efforts represent the first steps in understanding the Moon's history and resources while paving the way for future exploration and habitation missions. According to the Indian Space Research Organization, ISRO, the Vikram lander achieved a highly accurate landing despite the challenging terrain. Instruments on board detected over 600 tons of potential water ice in the permanently shadowed craters, a discovery of great significance for both science and the space industry. This achievement is not only a source of pride for India, but also a powerful inspiration for humanity. It stands as a testament to the fact that, despite monumental challenges, humans can accomplish what once seemed impossible. Chandrayaan-3 is more than just a technological feat. It is a symbol of humanity's unyielding spirit to explore and conquer the universe. Imagine standing on a barren lunar surface where every inch holds valuable information about billions of years of cosmic history. Chandrayaan-3 acts as a modern archaeologist, uncovering secrets buried in eternal darkness. Each piece of data collected is not just a number, but a story about the past, helping us understand our place in the cosmos. Additional scientific data from previous missions like Chandrayaan-1 and 2 show that the South Pole has the best conditions for preserving water, with approximately 40% of the Moon's water ice concentrated in this region. These findings lay the groundwork for further research into using this water for long-term human missions. Chandrayaan-3 is not merely a spacecraft. It is a testament to human ingenuity and creativity, pushing the boundaries of technology to explore new horizons. Beneath the cold, hard lunar surface lies a treasure trove of knowledge waiting to be uncovered, opening the door for future generations to step through. Discoveries from Chandrayaan-3 extend beyond the Moon itself. They mark the beginning of our journey to better understand the shadowed regions on other planets. Upcoming missions like NASA's Artemis and Russia's Luna 27 will continue this exploration, aiming to unlock resources and establish human presence beyond Earth. Geological and chemical discoveries from Chandrayaan-3. Chandrayaan-3, utilizing LIBS technology to detect sulfur on the lunar surface. Have you ever imagined that a tiny laser beam could unlock secrets billions of years old on the Moon? This is exactly how Chandrayaan-3 used the cutting-edge LIBS laser-induced breakdown spectroscopy technology to detect sulfur on the Moon's surface, a groundbreaking discovery confirmed for the first time in human history. This achievement is not just a technological marvel, but a gateway to new insights into the geology and chemistry of our celestial neighbor. LIBS is one of the most advanced technologies deployed in the Chandrayaan-3 mission, enabling direct analysis of chemical compositions on the Moon's surface. The technology works by firing a high-powered laser beam onto the target material, vaporizing it into plasma. The emitted light from the plasma is then analyzed to identify the elements present. Using LIBS, Chandrayaan-3 identified sulfur on the Moon's surface, a discovery that had never been confirmed before. Sulfur is not only a common element in geological processes, but also offers clues about ancient volcanic activity and critical chemical reactions on the Moon. This discovery raises fascinating questions about sulfur's origin, its role in lunar geology, and its potential applications for future resource utilization missions. According to reports from the Indian Space Research Organization, ISRO, LIBS aboard Chandrayaan-3 precisely identified sulfur's presence in the Moon's southern polar regions. This analysis was conducted directly on the lunar surface, eliminating the need to bring samples back to Earth. This milestone demonstrates significant advancements in situ analysis technologies, reducing costs and time for space exploration missions. Imagine this: each laser beam fired acts like a scientific key, unlocking secrets hidden within the Moon's crust for billions of years. This discovery not only helps us better understand Earth's natural satellite, but also inspires future generations to continue humanity's journey of cosmic exploration. A relatable comparison would be soil analysis in agriculture. Modern analytical tools, similar to LIBS, are used to identify the chemical composition of soil, helping farmers optimize their crops. Chandrayaan-3, equipped with LIBS, performs a similar function, but on a cosmic scale, unraveling the Moon's geological history for scientists. Additional studies from ISRO reveal that LIBS aboard Chandrayaan-3 can detect elements with incredible precision, down to parts per million, ppm. This capability extends beyond sulfur, enabling the identification of other elements like aluminum, calcium, and manganese. Such findings are crucial for developing hypotheses about how the moon was formed. LIBES is more than just an analytical tool. It symbolizes human ingenuity and determination to push the boundaries of science and technology. Through each laser pulse, we unlock new horizons of knowledge, delivering value not only for science, but for the future of humanity. The discovery of sulfur is not an isolated achievement. It connects with other identified elements to form a comprehensive picture of the moon's geology. This also suggests potential applications in technology and space development. Elements like sulfur could be used to generate energy or as raw materials in future space missions. Other elements, such as aluminum, calcium, iron, and manganese, were found, providing more insights into the moon's geological structure. The moon's surface isn't just a barren wasteland. It holds hidden treasures, elements like aluminum, calcium, iron, and manganese, that tell stories of the moon's formation and evolution over billions of years. These familiar elements are now unlocking new chapters in lunar science thanks to Chandrayaan-3's exploration. As Chandrayaan-3 analyzed the lunar surface near the South Pole, it confirmed the presence of elements such as aluminum, calcium, iron, and manganese, key contributors to geological processes. Aluminum and calcium are often linked to minerals formed as magma cools, indicating that the moon's surface was once a molten ocean of magma. Meanwhile, iron and manganese hint at complex chemical reactions, shaping the crust and core over time. These findings not only illuminate the moon's origins, but also pave the way for studying how these elements interact in shaping its current geological landscape. According to data from Chandrayaan-3 and earlier missions, aluminum and calcium were found in higher concentrations in the South Pole region compared to other lunar areas. The mission's advanced analytical tools precisely measured the presence of these elements, delivering critical insights into the moon's complex geological structure. Imagine each element found on the moon as a letter in a vast book. When pieced together, they form a narrative about how the moon came to be and evolved over billions of years. These discoveries are not only scientific milestones, but also inspirations for humanity's unending drive to explore. For example, on Earth, elements like aluminum and iron are essential in construction and industry. Similarly, on the moon, they could serve as building blocks for resource extraction facilities or even space bases for future missions. Beyond aluminum and calcium, Chandrayaan-3 detected significant amounts of manganese and iron, elements often associated with magnetic properties. This suggests that the South Pole might have undergone unique geological processes, potentially involving magnetic interactions in the past. These elements are more than mere data points. They raise intriguing questions. Aluminum, iron, and manganese on the moon could become the raw materials for constructing a spacefaring future, from housing modules to energy systems. The discovery of elements at the moon's South Pole not only sheds light on the moon's history, but also broadens our vision for utilizing space resources. These findings, connected to other discoveries, are building a more comprehensive picture of the moon's geology and its potential as a cornerstone for humanity's ventures into space. Measuring surface and subsurface temperatures reveals the moon's soil has high insulation properties, vital for future missions. Have you ever wondered how the seemingly lifeless lunar soil could possess a property so critical it could redefine how we approach space exploration? Findings from Chandrayaan-3 have shown that this soil is more than just barren dust. It's a natural insulation system with immense potential to support humanity's long-term space missions. Data from Chandrayaan-3 revealed that the moon's soil, or regolith, has high thermal insulation properties, maintaining stable temperatures at varying depths, despite extreme surface conditions. On a surface where temperatures swing dramatically from -250 degrees Celsius at night to 120 degrees Celsius during the day, this soil acts as a natural protective blanket. This not only shields buried infrastructure from thermal fluctuations, but also creates favorable conditions for future long-term missions. Thermal measurements from Chandrayaan-3 demonstrated that at a depth of just 10 centimeters below the surface, temperatures remain stable at around -20 degrees Celsius, an extraordinary discovery with far-reaching practical implications. According to ISRO, the lunar soil's thermal stability and insulation properties significantly mitigate the harsh effects of the Moon's environment. These findings are not only scientifically significant, but also pave the way for new opportunities in constructing lunar bases. The soil could serve as a foundation for habitation modules, fuel storage facilities, or even naturally regulated thermal systems. Thinking about this possibility, it's easy to draw a parallel with how homes on Earth are built with insulation materials to maintain stable indoor temperatures. Similarly, the lunar soil could act as a natural construction material, safeguarding future human and technological endeavors from the harshness of outer space. Furthermore, upcoming missions like NASA's Artemis and Russia's Luna 27 can utilize this data to optimize the design and construction of space infrastructure. With natural insulation properties, this soil could reduce the energy needed for thermal regulation, a critical factor in long-term missions. Beyond its practical uses, this insulating soil sparks visions of a future where humans live and work beyond Earth. It's not just a physical shield, but also a symbol of how science and life, nature and technology can coexist and thrive in the harshest environments. This discovery opens a new chapter, not just in understanding the Moon, but also in laying the groundwork for missions to other planets. Could the soil on Mars or other moons possess similar properties? This remains a question for scientists of the future as humanity's journey of exploration continues. The potential of water and the future of lunar exploration. Chandrayaan-3 has not directly detected ice water, but research suggests water may be cold-trapped in shadowed craters. Have you ever wondered if water could exist, trapped in eternal darkness, in places where sunlight never reaches on the Moon? These permanently shadowed regions are more than mere darkness. They are natural storage sites where water could have been preserved for billions of years. This is what Chandrayaan-3 has hinted at, even though it has not directly detected ice water. Its research provides compelling evidence of water existing in this unique, cold-trapped state. Scientists have determined that the permanently shadowed craters at the Moon's south pole offer ideal conditions for preserving water in its frozen form. These regions, with temperatures consistently below -250 degrees Celsius, remain unaffected by sunlight or heat, creating perfect environments for ice to remain stable. Data from Chandrayaan-3 indicates that while the rover has yet to physically reach the ice, its readings of hydrogen levels and the terrain structure suggest that water may be present as ice, cold-trapped in craters several kilometers deep. This discovery is significant, as water is not only essential for life but can also be utilized to produce energy or fuel for future space missions. According to NASA and studies from the Lunar Reconnaissance Orbiter, ice water could make up as much as 10% of the soil mass in these shadowed regions. This promising figure underscores the potential for harvesting lunar water to support long-term space missions. Imagine these shadowed craters on the Moon as cosmic safes, tightly guarding precious water in extreme conditions. They are not just repositories of resources, but symbols of survival and hope for a future where humanity extends its presence beyond Earth. A relatable example is the ice caves found at the poles on Earth. Despite harsh environmental conditions, the ice in these caves has persisted for millions of years, preserving not just water, but also valuable climatic information. Similarly, the Moon's shadowed craters serve as reservoirs, holding not only water, but also clues to the history of the solar system. Data from instruments such as ground-penetrating radar and hydrogen sensors on Chandrayaan-3 reveal that these shadowed regions could store millions of tons of ice water, a quantity sufficient to supply water and fuel for numerous future space missions. These findings are not only scientifically significant, but also evoke a sense of wonder at how the Moon, seemingly barren, harbors such invaluable resources. We are at the cusp of a breakthrough, not only in understanding the Moon better, but in potentially turning it into a launch pad for deeper space exploration. Exploring the potential of water on the Moon is not just about cutting-edge technology like Chandrayaan-3. It is also a testament to human perseverance and creativity in achieving the impossible. This discovery paves the way for a promising future and inspires us to ask, could similar cold traps exist elsewhere in the universe? This will be the next mission for humanity. Compounds related to sulfur and other elements may provide clues about the existence and decomposition of water. Have you ever wondered if elements like sulfur or calcium could hold the key to a billion-year-old story about the presence of water on the Moon? Chandrayaan-3, through its analysis of chemical compounds on the lunar surface, has unveiled significant evidence. These seemingly unrelated elements harbor clues about the complex history of water and the chemical reactions that occurred there. Sulfur, detected by Chandrayaan-3, is commonly associated with geological processes involving water. When water interacts with sulfur-containing minerals, it can produce compounds like sulfates, often indicators of the presence or breakdown of water in the past. Additionally, elements such as aluminum, calcium, and manganese play crucial roles in analyzing the Moon's chemical environment. These elements may interact with water, forming unique minerals that provide valuable insights into the Moon's geological history and environment. This discovery not only sheds light on the past presence of water on the Moon, but also opens new research directions on how water exists and decomposes under extreme conditions. According to reports from ISRO and NASA, compounds containing sulfur and hydrogen, along with traces of calcium minerals, were identified in the lunar South Pole region. The data suggests that this arid environment might have supported water in specific periods before it decomposed or became buried beneath layers of soil. These findings are crucial, strengthening the hypothesis that water may have existed and might still be cold-trapped in the Moon's permanently shadowed craters. Imagine each chemical element detected by Chandrayaan-3 as a piece of a giant puzzle that forms a panoramic view of the Moon's history. When assembled, they not only reveal the past of this satellite, but also illustrate water's role in shaping its geology and chemical environment. This is not just a tale of science, but a symbol of humanity's desire to uncover the origins of life and existence. For instance, on Earth, sulfur-containing minerals are often found in ancient volcanic regions, preserving traces of chemical processes that occurred millions of years ago. Similarly, on the Moon, sulfur and other elements may hold records of periods when water existed, even if only under transient conditions. Chandrayaan-3's research further indicates that sulfur and related compounds may be remnants of chemical reactions from the Moon's early days. These findings not only provide geological insights, but also suggest the potential use of these elements as resources for future space missions. The discovery of sulfur and other elements is not just scientifically significant, but also heralds a new chapter in humanity's quest to explore the universe. These findings are more than data. They are inspiring pieces reminding us that every element, no matter how small, plays a crucial role in telling the story of the solar system. Chandrayaan-3's discoveries go beyond exploring the history of water on the Moon. They lay the groundwork for deeper research, paving the way for future missions to determine whether other planets in the solar system might hold similar secrets. The success of Chandrayaan-3 lays the foundation for future missions, such as LUPEX 2026, a collaboration between ISRO and JAXA, and Chandrayaan-4, aimed at bringing lunar samples back to Earth in 2028. Have you ever wondered how a single achievement can ignite an entirely new chapter in humanity's journey to explore the universe? Chandrayaan-3 has become a stepping stone for even grander aspirations, not only for India, but also for international collaborations. Its success is not just a scientific milestone, it has laid a solid foundation for future missions, such as LUPEX 2026, a joint project between ISRO and JAXA, and Chandrayaan-4, aimed at bringing lunar samples back to Earth in 2028. Chandrayaan-3 proved that a soft landing on the Moon's south pole is achievable, a feat no other nation had accomplished before. By providing invaluable data on the terrain, temperatures, and chemical composition, Chandrayaan-3 has become a trailblazer, paving the way for more ambitious missions. LUPEX, slated for 2026, will build on this success by focusing on detailed studies of water and ice compounds at the South Pole. Meanwhile, Chandrayaan-4, scheduled for 2028, will mark a significant milestone as it aims to return lunar samples to Earth, offering unprecedented insights into the Moon's history and structure. According to data from ISRO and JAXA, LUPEX will feature advanced instruments, including ground-penetrating radar and ice analyzers, to further explore shadowed craters and cold traps. Scientists expect this mission to pinpoint the location and quantity of water, opening up practical applications for space resource utilization. The success of Chandrayaan-3 has not only delivered scientific data, but also ignited powerful inspiration among millions. It stands as a testament to the power of perseverance, creativity, and international collaboration in overcoming challenges that once seemed insurmountable. It gives us hope that with every step forward, humanity moves closer to its goal of living beyond Earth. Imagine a team of scientists and engineers from multiple nations working together on a shared space mission, exchanging data and resources to achieve extraordinary goals. Chandrayaan-3 has set the stage for this era of international cooperation, and LUPEX will be the next milestone, combining the expertise of India and Japan in lunar exploration. In tandem with LUPEX, Chandrayaan-4 will be India's first mission to return lunar samples to Earth. These samples will be analyzed to determine their detailed chemical composition, offering new insights into the geological processes that shape the Moon. This will not only enhance our understanding of the Moon, but also lead to new hypotheses about the origins and evolution of the solar system. The success of Chandrayaan-3 is a clear reminder that the limits of science and technology exist only as long as we stop exploring. With LUPEX and Chandrayaan-4, we are not only advancing our knowledge of the Moon, but also preparing for the journey to conquer other planets in the solar system. Chandrayaan-3, LUPEX, and Chandrayaan-4 are not just space missions. They are symbols of human dreams, collaboration, and perseverance. They remind us that every achievement begins with a single step, and that step can unlock a future without boundaries. Exploring exoplanets in the universe. Exoplanets are planets beyond our solar system, first discovered in 1992. To date, over 5,000 exoplanets have been confirmed with diverse types, such as gas giants, rocky planets, and super-Earths. Have you ever wondered if one of those countless twinkling stars in the night sky harbors a planet hiding secrets of life? This question has driven humanity from curiosity to groundbreaking discoveries in astronomy. A pivotal moment came in 1992 when two astronomers, Alexander Wolszczan and Dale Frail, confirmed the existence of exoplanets, planets orbiting stars other than the Sun. This revelation not only reshaped our understanding of the universe, but also opened a path to discovering thousands of diverse worlds, from massive gas giants to promising super-Earths. Exoplanets, or extrasolar planets, are defined as planets outside the solar system that orbit stars located hundreds to thousands of light years away. Since the first two exoplanets were identified in 1992 in the pulsar system, PSRB 1257+12, the field has seen explosive growth. According to NASA's Exoplanet Archive, over 5,000 exoplanets have been confirmed as of 2023, spanning a range of shapes and sizes. These planets can be classified into four main groups: gas giants, rocky planets, super-Earths, and icy planets. This diversity not only enhances our understanding of planetary formation, but also expands the potential for finding worlds that could support life beyond the solar system. Data from the Kepler Space Telescope indicates that among the 5,000-plus exoplanets discovered, roughly 30% are gas giants like Jupiter and Saturn. 35% are rocky planets similar to Earth, and 31% are super-Earths, planets larger than Earth but smaller than Neptune. These numbers highlight the remarkable variety of exoplanets and confirm that the universe holds far more surprises than we ever imagined. Imagine waking up one day to the realization that Earth is not the only place where life could exist. Discoveries of exoplanets act as beacons of hope, sparking endless curiosity about alien worlds. The idea that each star might host its own mini-solar system with unique planets encourages us to believe in the possibility of life beyond our planet. Consider searching for a new home for your family. Each exoplanet resembles a potential home, where scientists assess whether the living conditions are suitable. Some planets, like super-Earths, might even offer better living conditions than Earth due to their larger masses, which can maintain thicker atmospheres and better protection against cosmic radiation. A study by the ESA revealed that about 200 to 300 new exoplanets are discovered annually, thanks to advanced telescopes like TESS and JWST. This number is expected to rise significantly as cutting-edge technologies like the LUVOIR and aerial telescopes come online. Exoplanets are not just scientific subjects, but also sources of boundless inspiration. They appear in sci-fi films like Interstellar and Avatar, igniting our imagination about distant worlds with entirely different forms of life. Exploring exoplanets feels like stepping into a new chapter in the universe's grand storybook, where every page holds wondrous surprises. With continuous advancements in technology, studying exoplanets not only broadens our knowledge, but also brings us closer to answering the ultimate question: are we alone in the universe? And if not, which planet will be our most welcoming neighbor? Some exoplanets are located in the Goldilocks zone, a region with temperatures ideal for liquid water. Notable planets in this category include Kepler 452b and TRAPPIST-1e, sparking hopes for the possibility of supporting life. Have you ever heard of the Goldilocks zone? This isn't a tale about a little girl and three bears, but rather an astronomical term describing regions with conditions perfect for liquid water. It's the area around a star where temperatures are neither too hot for water to evaporate nor too cold for it to freeze. Planets within this zone, such as Kepler 452b and TRAPPIST-1e, not only spark hopes for extraterrestrial life, but also stand as prime targets in humanity's quest to explore the universe. The Goldilocks zone is considered the sweet spot for life's essential conditions. Planets in this region typically have surface temperatures ranging from 0 degrees Celsius to 50 degrees Celsius, creating ideal circumstances for water, the cornerstone of life, to exist in liquid form. Kepler 452b, located about 1,400 light-years from Earth, is a prime example. This super-Earth, approximately 60% larger than Earth, receives a similar amount of sunlight from its sun-like star. Meanwhile, the TRAPPIST system, with its 7 planets, is particularly exciting, especially TRAPPIST-1e, which closely resembles Earth in size and orbits within the Goldilocks zone of a cool dwarf star. According to NASA, only around 1% of the over 5,000 confirmed exoplanets are located within the Goldilocks zone. While this number may seem small, it represents dozens of planets with potential for supporting life. This demonstrates that the search for distant worlds is not a far-fetched dream, but a goal firmly grounded in science. Imagine a world where you gaze at the sky to see not one, but 2 or 3 suns shining brightly, or where twilight is bathed in the soft blue glow of a cool dwarf star. The Goldilocks zone is not just a scientific concept, but a reminder of the wonders that might exist beyond our current understanding. Think of finding the perfect piece of land to build your dream home. Plenty of sunlight, access to water, clean air, and a stable environment. The search for exoplanets in the Goldilocks zone is much the same. We're looking for cosmic real estate that could sustain life. Recent studies reveal that the TRAPPIST-1 system has at least 3 planets within the Goldilocks zone. Notably, TRAPPIST-1e receives energy from its star comparable to what Earth gets from the Sun, increasing the likelihood of liquid water on its surface. Exoplanets like Kepler 452b and TRAPPIST-1e are not just scientific subjects. They symbolize humanity's boundless curiosity and hope. They open doors to thinking about life in entirely new ways, far beyond traditional frameworks. The Goldilocks zone not only offers hope for life beyond Earth, but also raises profound questions. If we find a planet with life, how will it reshape our relationship with the universe? Could these planets become the friendly neighbors we've been searching for? The discovery of exoplanets reveals the incredible diversity of planets in the universe. From scorching worlds orbiting close to their stars to frozen planets far away, expanding the prospects of life in varied forms. Have you ever wondered if there are planets in the universe with environments completely unlike Earth's, yet still capable of sustaining life? The exploration of exoplanets has painted an astonishingly diverse picture of worlds beyond our solar system. From scorching gas giants like WASP-12b, where temperatures are hot enough to melt metal, to icy planets like Ogle 2005 BLG 390LB, where temperatures plummet to minus 220 degrees Celsius, the universe is opening up endless possibilities for life in forms we've never imagined. The diversity of exoplanets is a vivid testament to the richness of the cosmos. WASP-12b, discovered over a decade ago, exemplifies the hot planets. Its surface temperature exceeds 2,200 degrees Celsius, causing it to be stripped apart by its parent star, forming a massive tail of gas reminiscent of a comet. On the other extreme, Ogle 2005 BLG 390 lies in a frigid realm, orbiting a red dwarf star with a climate seemingly inhospitable to life as we know it. This contrast not only highlights harsh environmental conditions, but also expands the search for life, as life, if it exists, might adapt to such extremes. According to NASA, over 35% of the more than 5,000 exoplanets discovered are rocky planets, while about 30% are gas giants. The rest include icy planets, or those not yet fully classified. These figures highlight the incredible diversity of planetary types, broadening the potential for finding life under conditions previously unexplored. Imagine a distant planet where sunsets last for weeks, or one where the parent star glows brightly in the night sky. Exoplanets are not just dry scientific subjects. They're profound sources of inspiration, hinting at extraordinary ways in which life might adapt and thrive. Think of extremophiles on Earth, microorganisms that thrive in extreme environments like hydrothermal vents or acidic lakes. This suggests that even on harsh planets like WASP-12b or OGLE 2005 BLG 390LB, life could exist in forms yet unknown to us. Data from the Hubble Space Telescope has revealed that many gas giants like HD 209458b contain water molecules in their atmospheres. This raises the possibility that planets previously deemed uninhabitable might still harbor the basic building blocks of life. The diversity of exoplanets is like a colossal jigsaw puzzle, where each planet is a unique piece contributing to the story of the universe's evolution. Imagine a future where we not only find life, but also learn how it has adapted, expanding our understanding of ourselves in the process. From blistering hot planets to distant icy worlds, the discovery of exoplanets not only reshapes how we view the universe, but also poses greater questions about life and our place within it. And this story is far from over, with thousands more planets waiting to be unveiled. Tools and technologies for studying exoplanets. Using advanced telescopes like the Kepler Space Telescope, TESS, and JWST to observe and identify exoplanets. Have you ever wondered how scientists can see planets beyond our solar system, thousands of light years away? Though these planets don't shine like their parent stars, advanced telescopes such as Kepler, TESS, and JWST allow us to explore and identify these distant alien worlds. These cosmic eyes not only observe, but also deliver crucial data to help us better understand our place in the galaxy. Launched in 2009, the Kepler Space Telescope revolutionized how we detect exoplanets through the transit method. By measuring tiny dips in a star's brightness when a planet crosses in front of it, Kepler confirmed over 2,700 exoplanets before retiring in 2018. Following Kepler's legacy, the TESS, Transiting Exoplanet Survey satellite, launched in 2018, focused on stars closer to our solar system and has already discovered more than 600 exoplanets. Particularly, the JWST, launched in 2021, has taken this mission further by not only identifying planets, but also analyzing their atmospheres, opening a new chapter in the search for life beyond Earth. According to data from NASA, over 75% of the more than 5,000 exoplanets discovered so far were identified using the transit method. These telescopes have uncovered planets of all kinds, from scorching hot gas giants to promising super-Earths. Imagine these technological marvels like Kepler or TESS reaching out to the farthest corners of the universe, bringing back messages from planets we never knew existed. These cosmic eyes are not just scientific tools, but also representations of humanity's boundless desire to explore. For instance, Kepler discovered Kepler 452b, a super-Earth in the Goldilocks zone, potentially capable of supporting life. Located about 1,400 light-years from Earth, this discovery was made possible thanks to telescopes, enabling us to confirm its existence and study its fascinating features. Additionally, a study from the European Space Agency, ESA, revealed that in 2021 alone, TS identified over 150 potential planets, adding to the ever-growing list of candidates for further exploration. Telescopes like Kepler and TESS are not merely scientific instruments. They are powerful sources of inspiration,
provided data that has helped to redefine our understanding of 1,000 of which have been confirmed.
We come closer to understanding the universe and ourselves. The advancements in telescopes also lay the groundwork for the future, as missions like Ariel and Louvoir build upon the successes of Kepler and TESS. These new cosmic eyes will not only observe, but also dive deeper into the atmospheres of exoplanets. The JWST brings breakthroughs in analyzing the atmospheres of exoplanets. Elements such as water vapor, methane, and carbon dioxide have been detected, suggesting the possibility of prebiotic conditions. Have you ever imagined that humanity could smell the air of planets located thousands of light-years away? What once seemed like an unattainable dream has now become reality, thanks to the groundbreaking capabilities of the James Webb Space Telescope, JWST. As one of the most advanced technological achievements in astronomy, the JWST not only observes these distant worlds, but also analyzes their atmospheric compositions, offering us unprecedented insights into the possibility of prebiotic conditions on other planets. The JWST is revolutionizing how we study exoplanets, particularly their atmospheres. Operating in the infrared spectrum, this telescope detects even the faintest molecular signals from distant exoplanets. Recent observations of WASP-39b, a gas giant, revealed the presence of key atmospheric molecules such as carbon dioxide, water vapor, and methane. This discovery marked the first time such essential components for life were detected with such precision. The findings showcase JWST's ability to peer into alien worlds like never before, while also hinting that conditions suitable for life might exist elsewhere in the universe. According to NASA, these molecules on WASP-39b were detected using JWST's NIR SPEC instrument. This powerful tool enables scientists to determine the composition and structure of planetary atmospheres, offering clues about their origin and evolution. Such capabilities represent a monumental leap forward in our efforts to identify biosignatures, indicators of life, on planets similar to Earth. Imagine the JWST as a giant nose for humanity, enabling us to sniff out the secrets of planets far beyond our reach. This capability doesn't just amaze us, it also inspires hope that we might one day confirm the existence of life or conditions suitable for life in the farthest reaches of the cosmos. Let's draw a simple comparison. Imagine using a high-tech air quality monitor to analyze your environment. JWST operates on a similar principle, except it measures the atmospheric components of planets thousands of light-years away. This level of analysis is not just groundbreaking, it's transformative in our quest to understand the cosmos. The ESA reports that JWST's instruments, such as MIRI and NIRCam, are also equipped to detect smaller planets closer in size to Earth. This capability has significantly increased our chances of identifying habitable worlds in the near future. By exploring the atmospheres of these planets, JWST is paving the way for the next generation of discoveries that could redefine our understanding of life in the universe. The James Webb Space Telescope is more than a scientific tool. It is a symbol of human ingenuity and ambition,
Amazing
Its
images of
success
space.
demonstrates how far we've come in our pursuit of knowledge and how much further we are willing to go. By analyzing atmospheric compositions and uncovering molecular secrets, JWST is opening a new chapter in our exploration of the cosmos. The work of JWST represents only the beginning. Future missions like Ariel and Louvoir will build upon these findings, pushing the boundaries of what we can detect and analyze even further. These missions promise not only to deepen our understanding of the atmospheres of distant planets, but also to expand the scope of our search for extraterrestrial life. Future missions like Ariel and Louvoir are expected to provide direct imaging and deeper analysis of exoplanets in the coming decade. Have you ever wondered if one day we could see direct images of planets beyond our solar system? Missions from advanced telescopes such as Ariel and Louvoir aim to turn this once impossible vision into reality. These telescopes will not only capture detailed images of exoplanets, but also open the door to deeper investigations into their atmospheres, surfaces, and potential to support life on these distant worlds. In the next decade, missions like Ariel and Louvoir promise to revolutionize exoplanet research. Ariel, a project by the European Space Agency, ESA, scheduled for launch in 2029, is designed to analyze the atmospheres of over 1,000 exoplanets. Equipped with cutting-edge instruments, Ariel will measure atmospheric temperatures, chemical compositions, and characteristics, providing a comprehensive view of these planets. Meanwhile, NASA's Louvoir, large UV optical infrared surveyor telescope, still in development, will not only capture direct images of Earth-like planets, but also delve deeper into identifying biosignatures in their atmospheres. According to ESA, Ariel will focus on planets orbiting a wide range of stars, from red dwarfs to giant stars, delivering comprehensive data on atmospheric structures and the potential presence of water. Furthermore, Louvoir, with its higher resolution compared to JWST, could analyze planets nearly identical in size to Earth, located in the habitable zone. Scientists predict that Louvoir could detect over 30% of potential exoplanets in this region. Imagine the day we can witness the skies of a distant planet, where clouds of methane drift gently, or the light of its parent star reflects off a sparkling alien ocean. Ariel and Louvoir are not just scientific missions, they are a testament to humanity's insatiable curiosity and drive to uncover the mysteries of the cosmos. Think of how Google Maps allows us to explore every corner of Earth. Similarly, Ariel and Louvoir will serve as cosmic maps, building a detailed atlas of planets beyond our solar system. These telescopes are not only scientific instruments, but also symbols of human progress and innovation. In addition to Ariel, Louvoir promises high-resolution direct imaging capabilities. According to NASA, Louvoir's primary mirror will range from 8 to 15 meters in diameter, far surpassing JWST's 6.5 meters. This scale will enable Louvoir to observe planets thousands of light years away, vastly expanding our reach into the cosmos. Imagine each exoplanet as a chapter in a colossal book about the universe, with Ariel and Louvoir acting as the authors of these new discoveries. Every piece of data collected is not just a number. It is a reminder that we live in an infinite universe filled with wonders waiting to be unveiled. The missions of Ariel and Louvoir not only open new horizons, but also lay the groundwork for future technologies. These telescopes will serve as the eyes for the next generations, building on the discoveries of JWST and bringing us closer to answering the ultimate question: are we alone in the universe? The significance of studying exoplanets. Understanding exoplanets helps us compare and contrast with the solar system, shedding light on the mechanisms of planetary formation and evolution. Have you ever wondered why studying exoplanets is so important? The journey to explore planets beyond our solar system doesn't just lead to fascinating discoveries. It also helps us gain a deeper understanding of our own home, the solar system. By comparing and contrasting with exoplanets, scientists can decode the mechanisms of planetary formation and evolution, a grand story in which Earth is just a small chapter. Exoplanets offer an enormous natural laboratory for studying planetary systems across the universe. Our solar system, with its unique features ranging from rocky planets like Earth to gas giants like Jupiter, is just one among billions of planetary systems. By studying exoplanets like HD 209458b, a hot gas giant orbiting extremely close to its star, we learn that not all gas giants maintain a safe distance like Jupiter. These planets migrate from distant orbits to close proximity during their formation, a phenomenon absent in our solar system. Such observations provide invaluable insights into the diversity and factors influencing planetary system development. According to a NASA report, over 75% of the more than 5,000 exoplanets discovered show planetary system patterns vastly different from the solar system. This reveals that the solar system is not the only standard model, and this diversity helps explain the essential factors needed to support life. Imagine looking at hundreds of different paintings, each telling a unique story of formation and evolution. Studying exoplanets is much the same. Each planet is a puzzle piece in the grand picture of the universe, helping us better understand its origins and workings. For instance, Kepler 11f is a small planet, orbiting very close to its star, situated within a tightly packed planetary system containing 6 planets. This system contrasts sharply with the solar system, where planets are spread far apart. Such differences illustrate that there is no single fixed model for planetary formation. Data from the Kepler telescope also reveals that planets similar in size to Earth, but orbiting red dwarf stars, are far more common than larger planets. This statistic reshapes our perception of the solar system's uniqueness and broadens our perspective on factors that may support life. Picture each exoplanet as a map, where every piece of data collected is a doorway to a story about the formation and evolution of the universe. These stories not only illuminate the past, but also provide a clearer view of the future. Comparing and contrasting with exoplanets is not just a scientific journey. It is a journey of self-discovery. Through this research, we gain not only a deeper understanding of the universe, but also a clearer sense of our place within it. This is not just a process of exploration, but a redefinition of what it means to exist in an infinite cosmos. The discovery of exoplanets helps answer big questions. Have you ever wondered, are we alone in the universe? This is one of humanity's greatest questions. And thanks to the remarkable advancements in space science and the discovery of exoplanets, we are closer than ever to unraveling the mysteries of the cosmos. Each planet discovered is not just a distant point of light, but a piece of the larger puzzle that seeks to answer profound questions about life, our origins, and the vast universe itself. The exploration of exoplanets is key to addressing fundamental questions. Does life exist beyond Earth? How did the universe come into being? And what makes a planet capable of supporting life? Planets within the Goldilocks zone, such as Kepler 452b and TRAPPIST-1e, are prime candidates in the search for extraterrestrial life. These planets possess surface temperatures ideal for liquid water, a vital component for life as we know it. The existence of such planets not only hints at the possibility of life elsewhere, but also reshapes our understanding of Earth's uniqueness and the solar system. According to NASA, approximately 30% of discovered exoplanets are located in the Goldilocks zone, offering tremendous potential for finding biosignatures. Big questions hold a unique allure as they drive human curiosity and boundless exploration. Imagine the day when we receive a signal from a distant planet, a sign that we are not alone in this vast cosmos. Such a discovery would not only revolutionize humanity's understanding of the universe, but also ignite profound inspiration for the future. A relatable example is the study of the TRAPPIST-1 system. This small star hosts 7 planets, 3 of which are situated in the Goldilocks zone. Research on TRAPPIST-1 provides insights into conditions that support life and answers questions about the stability of small but enduring planetary systems. Beyond Goldilocks zone planets, studies have shown that extreme planets like WASP-12b can teach us more about the formation and evolution of planetary systems. Statistics from ESA indicate that over 70% of discovered exoplanets are gas giants, or planets orbiting very close to their stars, highlighting the inherent diversity of the universe. The discovery of exoplanets is not just science, it's a philosophical journey to find the meaning of life and humanity's place in the cosmos. These big questions push the boundaries of science and remind us that the journey of exploration is worthwhile, no matter the outcome. Each exoplanet discovered is not just an addition to a catalog, but a new chapter in the story of life and the universe. These chapters not only bring answers, but also raise new questions, present fresh challenges, and kindle even greater hope for the future. The study of exoplanets not only expands human knowledge, but also lays the foundation for future missions, including the possibility of migrating beyond the solar system if necessary. Have you ever imagined that one day humanity could leave the solar system to find a new planet to call home? This idea, once confined to science fiction, is gradually becoming a tangible possibility thanks to advances in science and technology. The study of exoplanets not only broadens our understanding of the universe, but also sets the stage for future missions, carrying the profound hope of exploring and conquering distant worlds. The study of exoplanets provides profound insights into other planets, supporting plans for future migrations beyond the solar system. Planets located in the Goldilocks zone, where conditions are ideal for liquid water to exist, are considered prime candidates for migration. Kepler 452b, a super-Earth approximately 1,400 light-years away, is a notable example. Data from the Kepler telescope indicate that this planet may have a stable climate and the potential for water, a prerequisite for life. According to NASA, over 30% of discovered exoplanets are in the Goldilocks zone, creating significant prospects for finding new homes for humanity in the future. Imagine a world where humans set foot on a new planet and build a new life. This is not just a dream, but the goal of countless generations of scientists and engineers. It ignites creativity, determination, and the boundless aspirations of humankind. A relatable example is the Breakthrough Starshot project, an ambitious mission to send ultra-fast probes to the Alpha Centauri system, where scientists suspect there may be planets capable of supporting life. This project not only tests the feasibility of reaching distant planets, but also lays the groundwork for advanced technologies, paving the way for deeper space exploration. According to ESA reports, future missions like Ariel and LUVOIR will not only focus on analyzing the atmospheres of exoplanets, but also provide detailed insights into their geological structures and climatic conditions. This helps us better understand planets that humanity might inhabit in the distant future. Picture each exoplanet as a gateway to a new world, brimming with endless opportunities and challenges. Research not only enables exploration, but but also prepares us to face unforeseen changes, such as climate change or resource depletion on Earth. The search for suitable planets is not just a scientific endeavor, but also a philosophical and humanitarian journey. It raises profound questions about our responsibility to this planet and future generations. Each planet discovered is not just a distant light in the cosmos, but a beacon of hope for life and humanity's continuity. The study of exoplanets is not merely a scientific pursuit, but a strategic preparation for the future. These exploratory journeys enrich our knowledge and push the boundaries of what humanity can achieve. From what we are discovering today, one day, humanity may reach distant stars and transform bold dreams into reality.